Blacksmithing. Do-it-yourself projects and information for a blacksmith or silversmith. Written by Arthur Livingston. Narrated by Nicholas Santaseer. Chapter 1. Who's a blacksmith? A blacksmith is a person who creates and shapes different metals into various other structures by using the method of forging. In forging, a blacksmith professional exposes metal to extremely high temperature so that it can melt and be clobbered into the desired size and shape. In fact, a blacksmith combines three processes to design and refine shapes required for the finished products, including welding, heat treatment, and finishing. Welding refers to the process of joining similar metals. Modern professionals utilize a wide range of blacksmith tools to complete the job, where arc welding and forge welding are some common types. Blacksmiths are considered as the best wielder of metals. The black in the blacksmith is derived from the color of the metal's outer layer, which, when oxidized, turns into color black, especially when heated. The word smith comes from the phrase smite, meaning to hit. A blacksmith uses devices like chisels, anvils, and hammers to shape, mold, and bend metals after they go through the heating process. This process is called forging. To finish their work, forge welding is done by the use of arc welding and oxyacetylene. To provide apt heat treatment, metals can be hardened, normalized, tempered, and annealed. This will change the original crystalline structure of steel so as to give it certain properties required for different purposes. Based on the determined purpose, a blacksmith can finish metal in many ways. Common blacksmithing tools. The most common blacksmith tools include a forge, tongs, hammers, vise, and anvil. Forge. Metal forge is actually a heat source and can be a solid fuel like charcoal, coke, or coal. It can also be gas fuel, such as propane. Solid fuel forge is considered easier to design. It is actually a depression which will hold coals and variable air blast that raise temperature. Anvil. This is a basic blacksmith tool and refers to a block with solid face on which other objects are struck. The accessories which are utilized with anvil may include dies, known as fullers and swages. The swage is just like stencil built of steel or iron and is always put between heated metal and anvil. Hammers. The options for hammers may vary from one blacksmith to another. At blacksmith shops, one can find a wide array of hammers in different sizes and weights. Sizes of hammerhead may vary, based on the shape which is to be made, with the largest ones being utilized for striking metal into the shape and small ones for finishing purposes. Tongs. Tongs are utilized to lift metals out of a forge and grip it whilst it is being processed. One can find a wide range of tongs in different shapes and sizes. The size of tong depends on the size of the metal being processed. The shape of gripping end will change, based on how metal is to be gripped and also whether this is to be twisted, bended, and hammered. Besides the above-mentioned basic blacksmithing tools, a professional doing creative work will also have certain tools for etching or embossing on metal. Blacksmiths should also have certain safety gears and precautions when working. When striking steel, there are many pieces of steel or parts that come off and fly that could hit one's skin and eyes directly. In order to avoid these risks, blacksmiths should always wear safety eyeglasses to keep the eyes safe. To create a specific heating, today's blacksmiths make use of oxyacetylene, which is the same as the blowtorch. The color of a metal is an important sign of its workability and temperature. A forging heat, or a color of vivid yellow-orange, is the most excellent sign of heat for the forging. Forging is a method in which a hammer is used to form a metal. Heat treatment is the process by which the metal is put into heat until it is ready for molding. The rough metal outer layer is polished to make it smooth and to make the product look furnished and to ensure the product will be of the highest quality. The workplace for blacksmiths is usually a danger-prone area. They are often working with fire and scalding that makes them more prone to accidents. Eyes are usually affected by the fire ignited from the metals that they are currently working with. Poisoning from metals and heat fatigue are also a frequent danger they face. Chapter 2. Welding and Forge Welding. Fabrication, particularly when linked to industry, implies the building of structures, machines, products, or other equipment by stamping, cutting, shaping, joining, and even assembling components from raw materials, most often metals. It is commonly considered standard to assume that a fabrication operation includes welding as well, but I have chosen to separate this as some welding operations are now very specialist techniques and they merit their own section in this book. Fabrication shops. Often, a small business that specializes in this type of work is known as a fabrication shop, but it should be noted that in most instances, the individual parts and metalworking activities will overlap with machine shop work and sheet metal engineering or sheet metal work. What sounds like a simple activity, such as cutting metal, can mean many different things from shearing, sawing, to cutting torches and water jet cutters, and finally to laser cutting tables and plasma cutting. Depending on the speed and accuracy of what you want, and cost and quality requirements, you will always need to check on the capabilities and capacities of the fabrication facility that you intend to use. In general terms, the fabrication and welding shop is likely to cover many of the following activities: cutting, burning, bending, wheeling, shearing, folding, forming, punching, milling, tapping, turning, welding, soldering. Welding. Welding is often a major part of metal fabrication, and many formed parts and assemblies will be tack welded together prior to being checked for accuracy and fit. Welding is a fabrication method which is predominantly about joining metals or thermoplastics by causing coalescence, which is commonly achieved by melting the parts, adding a filler material to form the weld pool which, when cooled, becomes a very sturdy joint, the weld. This is different from brazing and soldering, which does not induce melting of the initial components, but melts a material between the components to form a bond between them. There are lots of different forms of energy which can be used for welding other than the gas flame most of us recognize, like laser, electric arc, electron beam, friction, or ultrasound. Welding is a skilled operation and requires several safety precautions to avoid burns, shocks, eye damage, fumes, etc. Starting in blacksmith shops with forge welding, shielded metal arc welding is probably the most common form of welding used today, as well as the semi- and fully automated processes such as gas metal arc welding, MIG, and flux cord arc welding. As the technology advances ever onwards, so too do the welding systems like laser beam welding and electron beam welding. Some fabrication shops will offer specialist techniques such as MIG and TIG welding, which are briefly outlined below. MIG welding. MIG welding, metal inert gas, or metal arc welding, was originally developed for welding aluminum and other non-ferrous metals. It is usually an automatic or semi-automatic process, whereby an electrode joins two pieces of metal as a direct current is continuously passed through a welding gun. This is done at the same time as an inert gas is also passed through the gun, which stops any airborne contaminants entering the weld area. MIG welding allows the welding process to be much faster than other methods, which makes it ideal for welding softer metals, such as aluminum. It produces continuous welds faster than traditional methods, and produces cleaner welds. As it is very versatile, MIG welding can be used with a wide variety of metals and alloys. TIG welding. Tungsten inert gas welding, or TIG welding for short, is an arc welding process that uses a tungsten electrode to produce the weld. Similar to MIG welding in that the weld area is also protected from atmospheric contamination via an inert gas, usually helium or argon or a combination, and a filler metal is often used, although certain welds, called autogenous welds, do not require this. The constant current produces energy which in turn is conducted across the arc through a combination of ionized gas and metal vapors, which is known as plasma. TIG welding is often used to merge non-ferrous metals such as magnesium, copper alloys, and aluminum, and thin sections of stainless steel, and as the technique gives the experienced welder greater control over the weld, it has some advantages over MIG welding in that it can produce even higher quality and stronger welds. The filler rod is usually made from the same material as the base metal, and is used for reinforcing joints and welding heavy metals. Several joint types are used in TIG welding inclusive of butt joints, which do not always require the filler rod assistance, lap joints, corner joints, and T-joints. It is, however, more complex than MIG welding and harder to learn, and is much slower than most of the other techniques. Top fabrication shops. Finally, it is worthwhile checking to see if the fabrication shop offers other services which could be helpful to you. In today's fast-paced environment, it is worth seeing if your chosen supplier offers a one-stop shop, which could benefit you. Many will now offer other services such as design and prototyping, powder coating, assembly, testing and final inspection, packing and distribution. Some facts about welding process. Historical monuments, construction of building, bridges, shipbuilding, automobile, aerospace, power plants, refineries, and lots of manufacturing activities need the process, and welding is a part of it. The manufacturing industry came to know about the importance of service during the 20th century, and new equipment with the latest welding technology was introduced later, and requirement for welding supplies increased a lot. The welding industry should be equipped with modern tools such as electrodes, torches, consumables, and guns, and should follow the proper welding system with appropriate welding technology. There are different types of welding processes, and each one has its own merits and demerits. We talked about arc, MIG, and TIG welding, but there is also gas welding. Let me elaborate on that. Gas welding is also called oxy-fuel welding, and uses gases to weld and cut metals. Stick or shielded metal arc welding is a manual arc process that uses consumable electrodes. Plasma arc uses plasma gas and has narrow penetration with greater energy concentration. Plasma arc cutting is an easy process if you follow these safety precautions. Do not touch any wet surface when operating the plasma cutter equipment, and don't use plasma cutters without any proper protection. Don't remove the ground cable, which is attached with the work object, and ensure that there is proper earth since it connects with high electric circuit. In welding, electrode is used to conduct current, and it is of two types such as consumable one and a non-consumable one. Shielded metal arc, gas metal arc, flux cord arc, and submerged arc comes under the category of consumable electrode methods, and TIG and plasma arc are non-consumable electrode methods. Apart from the welding products such as MIG, TIG, stick, and submerged arc products, the other products such as wire feeders, spot welders, multi-process units, and water coolers comes under the welding products. Welding equipment is a heat-generating equipment, and it is needed to be cooled by some machines. Water coolers are the instruments which prevent overheating of machines. These have the motors which create a flow of water and cool the equipment. Tungsten electrodes are used in tungsten arc process. Tungsten electrode is used to weld stainless steel and non-ferrous metals, and it is called as a steel electrode. Chapter 3. Silversmithing. Tools of the Trade. In years past, it was hard to separate the silversmith, or just smith or smithy, from his tools. When you said smith, you were referring all at once to the person, his tools, and the place where he worked. The same is still true today. Without his tools, today's silversmith has nothing. I am passionate about tools. My father is responsible for instilling an appreciation of, and respect for, good tools. He always said that with the right tools, you can do anything. He also said that you should always buy the best tools that you can afford. In tools, cheaper is not always better. The term silversmith covers a very wide range of techniques and necessary tools. For some, it is still all about banging on metal with a hammer, and I will admit there is something very satisfying about pounding on metal. For others, it is mostly about soldering one thing to another. Because the solders are not soft and require higher heat than, say, electrical soldering, it is considered to be more like welding. But everyone simply refers to it as soldering. Silversmiths also engage in casting silver. I do not do that, and will not be discussing the tools required for casting. Regardless of what you are doing, you need tools. Here are some of the basics. If you are going to shape metal by pounding on it, you need something to pound with, and something to pound on. Hammers, bench blocks, anvils, and stakes. There are all sorts of hammers, and each one is good for one or maybe two purposes. An embossing hammer, when driven against the inner walls of raised work, can elevate positions of the surface. It may also be used for planishing. A planishing hammer is useful for smoothing out imperfections and finishing surfaces of pieces that have been raised. Raising hammers are used on the outside surfaces to force the basic shape of various objects. Ball-peen hammers are used for flattening, shaping, or removing dents. Riveting hammers are used for forming rivets and tacking. Chasing hammers have either flat heads or domed heads. Chasing can be thought of as a sort of stamping. Specially shaped punches are used to press a pattern or design into the metal. Most of these hammers will be made of drop-forged steel, but they may also be found in brass and nylon. Rawhide mallets are useful when you do not want marks of any kind left on your silver. For general all-around uses, I find a domed chasing hammer to be most handy. If you can afford only one hammer, that is the one I recommend. Bench blocks, anvils, and stakes fall into the same general category. They are what you hold the metal, either sheet or wire, against as you hammer it. Bench blocks come in a variety of shapes and sizes. In its simplest form, it is a square of hardened steel that sits on your workbench. The surface should be kept smooth and free of debris. I use one that is 4 inches square, and it is a fine size for most purposes. Blocks are also available with depressions in them in the shape of half of a ball. These are called dapping blocks and require a set of dapping punches. These are useful for doming. There are a number of other blocks with differently shaped depressions for all sorts of purposes. If you purchase an anvil, be sure the base is very solid and that it has a low center of gravity. Even so, it is sometimes a good idea to mount it to a piece of 2-inch by 6-inch board for stability. Anvils that have a cone on one side are particularly useful. Again, these come in all sorts of sizes and shapes. The size you choose will be determined by the size of the jewelry you wish to make. Stakes are hard to describe. They are made of hardened steel and can be held in place by a vise. They come in a wild array of shapes and sizes, and they are generally used for raising. There is one stake called a cow's tongue stake. It looks pretty much like its name. A bowl or vase that is being hammered into shape would be placed over the stake, and the metal would be struck from the outside against the stake. Whenever you hammer or bend metal, your work hardens it. It becomes more brittle the more that you work with it, and requires annealing to keep it from cracking and breaking. A torch, blacksmiths use a forge, is useful for annealing. A torch is necessary for soldering silver. If you are going to be soldering silver, you will need, at minimum, a torch, a soldering block, pickle, water for quenching and rinsing, copper tongs, silver solder, flux, and a flux brush. Protective eyewear is always a must. When I first started soldering silver, I wasn't at all certain that it was what I wanted to do. So, I started very small. I bought a butane-fueled mini torch, the kind you might use in your kitchen for making fancy desserts. No matter what you do, you absolutely need the other items mentioned above. That is, unless your only intention is to solder jump rings closed. Then a butane mini torch and silver paste solder in a syringe are all that you will need. Well, and something to polish them a bit when you are finished. I quickly learned that I liked soldering silver, and that in order to complete larger pieces, I was going to need a serious torch. I opted for a single fuel torch with 4 sizes of tips. The fuel I use is acetylene. The torch handle and tips are designed to mix the proper amount of atmospheric oxygen with the acetylene to get a nice hot flame. For the most part, the smallest size tip suffices for what I make. Occasionally, I use a larger one. I am glad that I have that option. Nothing is more frustrating than having this great idea and not having the tools you need to accomplish it. As far as soldering blocks, boards, and pads go, the smaller you can use, the better. The block is a heat sink, as is all the air around it, and the larger it is, the longer it takes to heat it up and heat the metal that is sitting on it. That is why some smiths prefer charcoal soldering blocks. They're usually small, and once you heat them up, they stay quite hot for a long time. And that is their main drawback. They can get so hot that it is uncomfortable to move your work around on them with your hands. Also, they tend to crack as they cool, and for this reason, it is best to wrap them with binding wire before you begin using them. There is a magnesia block option. They heat and cool quickly. They are not really made of magnesium, which is quite flammable. The surface of the soldering block does degrade and become pitted with each use, but they are easy to make true once again. I just move mine around on the concrete outside of our workshop with a circular motion, and in a few moments, it is nice and flat once more. There is a whole host of soldering boards that can be useful. They are made from a number of different materials. Some are of transite, which is very durable, non-asbestos, and withstands temperatures up to 2,800 degrees Fahrenheit. Ceramic soldering boards tolerate temperatures up to 2,000 degrees Fahrenheit. You can also purchase soldering pads made of calcium silicate. They also heat and cool quickly without cracking, and can be pinned into as the magnesia blocks. Once again, purchase the smallest surface for soldering on that you can use. It cuts down on the time needed to reach the melting point of your solder. Tripods with mesh screens are available that allow you to heat your workpiece from the bottom as well as the top. But keep in mind that all the air around your work will be sucking away the heat. I have one, but rarely if ever use it. Pickle is simply an acidic solution used to remove fire scale from sterling silver after it has been heated. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper. When you heat it, the copper is brought to the surface of the sterling silver. Copper is much more reactive with the moisture in the air than is pure silver. That, coupled with the heat speeds up the reaction, causes the copper to rust, or tarnish much more quickly, and the surface becomes quite black. Also, some fluxes will become quite glass-like after heating, and they also need to be dissolved. Granulated pickles that you mix with water are most common, and generally are not considered as hazardous materials, which require a very large shipping fee. Copper tongs are required for placing and removing objects from pickle. If an iron bearing tool is used, you will plate copper onto your sterling silver. It is a good idea to mix a little baking soda into your rinse water to help neutralize the acid completely. Silver solder basically comes in 4 hardnesses: extra easy, easy, medium, and hard. The silver paste solder mentioned earlier is basically extra easy. You will need all but the extra easy for most projects. The first joint is always made with hard solder. It melts at the highest temperature, and subsequent joins will, then, not unsolder the first join. Use medium and easy solders as you work your way through your piece. If you are using a new sterling silver called Argentium sterling silver, you cannot use the regular hard solder with it. Argentium has had some of the copper replaced with germanium and melts at a lower temperature than traditional sterling silver. You can purchase solders made specifically for use with Argentium. Flux is what helps the solder to flow. An anti-flux may be used to keep solder from flowing where you do not want it. I have not used anti-flux. Generally, the solder will follow the heat, so if you are careful about how you apply your flame, you should not have a problem. Fluxes are all toxic. Care should be used in handling them and managing the fumes given off as you are heating them. There are liquid fluxes and paste fluxes. Earlier, I briefly mentioned polishing. After pickling, your silver will have a dull, whitish coating. You can remove this with a soft brass brush dipped in a solution of dish soap and water. The soap keeps the brass from being deposited on the sterling silver. This will give a very soft shine to the surface. For a brilliant hard shine, you will need a buffing wheel of either cotton or muslin. The type that is stitched is best. It holds together longer and throws off less lint. These can be mounted in a regular drill that is mounted in place. Just be certain that the buff is rotating in a downward direction as you are looking at it. That way, if you let go of the work, it will fly down, back, and away from you, rather than into your face. There are also many motors available for purchase. Some will run only 1 buffing wheel, and some will run 2. There are many grades of polishing compounds. Some will cut quickly and remove large scratches. Others are for final polishing. Ideally, you should begin with metal that is as free of scratches as possible. Once your work is soldered together, it is not always easy to get to all the areas that require polishing. The compounds are held against the buffing wheel as it is spinning at speed. This is called charging the wheel. Hopefully by now, you have some idea of the basic tools you will need to begin your foray into silversmithing. It can be very fulfilling. It can sound very complicated on paper, but when it comes right down to doing it, it's not all that bad. I remember my delight at my first soldering closed of jump rings. At that moment, I was hooked. Oh yes, you will melt things that you did not want to melt. That is part of the learning process. Chapter 4. Olet Fittings, Branch Connection, and Types of Olet Fittings. Olet fittings, generally called branch connection fittings or outlet fittings, which give an outlet from a greater pipe to a littler one, or one of a comparative size. Olets are branching fittings made by largest manufacturers of metal fittings like us. Olets offer a substitute method for connecting into the primary run, and don't require fortification or reinforcement. Olets are pre-molded to the bend of the run pipe. Flat-based weldolets are accessible for connecting with pipe tops and vessel heads. The principal pipe onto which the branch connection is welded is for the most part called the run or header measure estimate. The pipe to which the branch affiliation or association gives a channel is called the branch or outlet measure. Branch connections are in all sizes, sorts, types, bores, and classes, in a broad assortment of stainless steel, chrome moly, and distinctive amalgams combinations. Outlets are mostly utilized for branching on high weight pressure and high temperature applications. Maximum admissible weight pressure of a fitting is same concerning connected straight, consistent, or seamless run pipe of proportionate material. Outlet pipe fittings materials and grades: weld-outlets, thread-outlets, sock-outlets. 1. Stainless steel outlet fittings. ASTM/ASME SA 182F GR 304, 304L, 304H, 304N, 304LN, 316, 316L, 316H, 316N, 316LN, 309L, 310, 317, 317L, 321, 321H, 347, 347H, and UNS 31254, 254 SMO. 2. Carbon steel outlet fittings. ASTM/ASME A105 /A350 LF2, ASME SA105, A694 F42, F46, F52, F60, F65, F70, A36, A516 GR 70, 60. 3. Alloy steel outlet fittings. ASTM/ASME A182 GR F1/F5/F9/F11/F22/F91. 4. Duplex steel outlet fittings. ASTM/ASME SA 182F GR F44, F45, F51, F53, F55, F60, F61, Workstoff number 1.4462. 5. Nickel alloy steel outlet fittings. ASTM/ASME SB 256 GR Nickel alloy 200, Nickel alloy 20, Monoalloy 400, Inconel alloy 600, Inconel alloy 625, Incalloy alloy 800, Incalloy alloy 800H, Incalloy alloy 800HT, Inconel alloy 825, Alloy 20, Hastelloy C-276, Hastelloy C-4, Hastelloy C-22, Alloy 6XN. 6. Low temperature pipe outlets. A/SA 350 LF2, LF3. Outlet fitting are also available in other metal like titanium, aluminum, bronze, lead, tantalum, zinc, brass, etc. Application or uses of outlet fittings are used in a wide range of industries. Some of them are power plants, water pipelines, refineries, food and beverages, pharmaceuticals, textiles, railways, petrochemicals, nuclear plants, sugar mills. Types of outlet pipe fittings. 1. Brazelet. Brazelet is usually generally and mostly to interface or associate the sustained fittings. Brazelet is the same as a weld-outlet and is an awesome fitting for metal pipes, copper tubing, and iron pipes funnels with brass. 2. Couplet. Couplet fittings are planned for use in fire/fire protection sprinkler structures and other low-weight channeling applications. 3. Elbowlet. Elbowlet is used on 90-degree long-radius elbows, can be delivered for short-radius elbows, for thermal well and instrumentation affiliations. 4. Flexolet. Flexolets resemble weldolets with a minor refinement, i.e., flexolet has straight bore, while weldolet has diminished bore. 5. Insert weldolet. Insert weldolet is the most broadly perceived of all branch associations, and is welded onto the outlet pipe. 6. Latrelet. Lateralets are an assortment of weldolets. You need to associate it in the same way. However, these lateralets make a 45-degree association with the standard pipe rather than a 90-degree. 7. Nippelet. Nippelets is just a mix of olets with pipe nipples. These olets work like the weldolets or threadolets, but they come with a nipple. 8. Sockolet. Sockolets are in a general sense like weldolets and threadolets, beside the root that in sockolets there is one-of-a-kind connection-suited welding. 9. Sweepolet. Sweepolet is a formed, basically sustained, butt-weld branch relationship with a low-stress heightening component for low weights and long depletion or exhaustion life. 10. Threadolet. Threadolets resemble diverse olets. The primary difference is that this olet is outfitted with female threaded association. 11. Weldolet. Weldolets, or welding olets, or welding branch association fittings, are the most understood among all the olets. These are for the most utilized and arranged as butt weld fittings, as these are welded into the branch pipe. Manufacturing standards. ASTM A182-ASME SA182. Standard specification. ASME B16.11. Forged fittings socket, welding and threaded. MSS SP-97. Integrally reinforced forged branch outlet fittings, socket welding, threaded and butt welding ends. Important industrial metal alloys and their uses. Metals in the form in which they are received from nature are not useful for many types of applications. The discovery of alloys is considered no less than a revolution that influenced a number of industrial applications in a big way. Today, iron and aluminum alloys, and those of a number of other metals like tin, cobalt, nickel, gold, and silver, form the base of many important industries. The advantage of alloys is that they exhibit properties of all the constituting metals. For example, these alloys exhibit better thermal properties, tensile strength, and wider range of melting points. Here are some sections about the most popular alloys, along with their industrial uses and applications. Copper alloys. Used for applications with low friction requirement. Brass is one of the popular metal alloys made by mixing copper with zinc. Valves, locks, bearings, and gears are some examples of these applications. Moreover, brass is known for its recyclable nature. Another common copper alloy is bronze, which contains tin as another constituent metal. Apart from being a popular material for sculptures, bronze is also widely used for making window weather stripping and automobile transmission bearings. Aluminum alloys. Needless to say, the aluminum alloys are the most popular materials that have great importance in many industrial uses. Consisting of aluminum, nickel, and cobalt, alnico is one of these alloys and is used in electric motors, cow magnets, sensors, and microphones. Duralumin is made of aluminum, copper, manganese, and magnesium, and is an extremely popular alloy for aircraft structures, truck wheels, auto body panel sheets, forgings, pistons, and many other applications. Among other aluminum alloys is magnesium, which is also used in many automobile and aircraft parts. Iron alloys. Iron needs no introduction for being a popular choice for many metal alloys like steel and stainless steel. Steel is extremely admirable for its high rust resistance, tensile strength, and welding ability. The alloy is a useful material for the construction of railways, roads, bridges, and skyscrapers. Stainless steel is a famous variety of steel and is used in making surgical instruments, industrial equipments, bridges, and aircraft and automobile body parts. Iron alloys with carbon as an important constituent are extensively accepted. Wrought iron, for example, has applications like manufacturing of gates and furniture items like racks, tables, desks, and chairs. Pig iron is used in blast furnaces, and different varieties of cast iron are used in machine tools, gears, crankshafts, and cooking accessories like pans. Other metal alloys. Tin is also used as the main constituent for many alloys like pewter and solder. While pewter is mainly used as a decorative material, solder is a widely used material for joining, called soldering, metals, for many important industrial applications. Sterling silver is a well-known alloy of silver. It is useful not only as a jewelry material, but also for making medical and musical instruments. Nichrome, an alloy of nickel, is used in explosive industry for electric ignition systems. Resistance wires made of this alloy, too, are popular. Chapter 5. History of Platinum Rings and Japanese Swords. Platinum is a chemical element that got mentioned first back in the 16th century in Europe. There is, however, evidence that this element was used in ancient Egypt and early South American civilizations in jewelry. It was Julius Caesar Scaliger, an Italian humanist, that made note of the metal in 1557 and named it Platina del Pinto, which in Spanish means a silver-like substance from Colombian Pinto River. Whereas gold has over the centuries been the major exchange in engagement ceremonies and weddings, platinum has become the most popular choice in the last decade. The strength and high melting point of this metal is what caught the attention of many scientists, but with plenty of extraction challenges of pure platinum, delays in use were experienced till the end of the 18th century. In 1786, the first successful extraction was made by Pierre-François Charbonneau, and in good amount for that matter. He later presented Pope Pius VI with a platinum chalice and went ahead to establish a production company to start the platinum age in Spain. From here, it started being used in different items, including royal crowns and utensils, military aircraft, and engagement rings. This precious metal is rare and remains to be amongst the rarest on the planet. This rarity, coupled with its tedious and prolonged extraction, makes it amongst the most valuable substances too. Platinum rings have brought in lots of competition to its gold counterpart, with most people, including celebrities, now choosing platinum engagement rings as romantic gestures and status symbols. Why the fame? Platinum rings have become very popular, majorly because of their high-quality finish that makes them stand out from other rings. These rings are also quite low in maintenance, making them some of the best for everyday rings, like wedding bands and engagement rings. The metal also has hypoallergenic properties. These properties push their popularity to the top of the list, especially for individuals with sensitive skin. While such people face problems wearing the other metals, they find comfort in platinum rings, making a huge difference. Platinum rings are versatile in terms of design. They can be made into any desired design without losing their quality and elegance. You will find impressive collections of trendy engagement rings, so you'll be lucky enough to have one designed just for you and to your exact specifications. Platinum is shiny and silky, although not that shimmery. This white metal is therefore very easy to work with any outfit, considering you will be wearing your engagement ring or wedding band every single day of your life. The gorgeous metal makes the fingers stand out, compared to what sterling silver or white gold can achieve. You will love how unique the rings look on and off. The rings have lifetime beauty. They simply maintain their elegance over the years, and with so little maintenance, they are just what you need. When you choose the perfect fit and design, you can be sure to enjoy your platinum ring for a lifetime. Properties and uses of alloy steel. A combination of steel with different elements in various proportions is called alloy steel. The low alloy steels are generally referred as alloy steels, ranging between 1% and 7%. They are chromium, nickel, molybdenum, and vanadium. It contains about 1% to 5% of steel that is combined with other elements. Different alloy elements have unique properties, and adding these elements improve various qualities. Adding chromium improves the temperature strength to heat treatment. Nickel is added to improve toughness. Molybdenum increases the strength of the material, and vanadium increases the deoxidizing capabilities and offers corrosion resistance. All low alloy steels provide good toughness, torsional, and fatigue strength. They also have photoactive and semiconducting properties that make them fit for electronics applications. They are used as good catalysts for various industrial applications. With a range of properties, they remain as the cost-effective additives that are combined with steel alloys. The common properties of alloy steel are corrosion resistance, machinability, hardenability, and weldability. Corrosion resistance. Corrosion is a phenomenon in which the metal is corroded or destroyed due to oxidation. This causes rusting of the metal surface. It has corrosion resistance properties to stop the rusting of the metal surface. Chromium, nickel, molybdenum, and vanadium alloys show high resistance to corrosion. Machinability. It is the capacity of the metal to undergo changes easily when subjected to various mechanical processes to get the desired result. Chromium, molybdenum, and nickel show very good machinability. In some cases, it should be annealed. Hardenability. It is the property of the steel alloy to be hardened after heat treatment and cooling. In this process, the metal transforms from an austenite to a martensite at a particular temperature condition. All the low steel alloys show good hardenability. Weldability. It is the ability of the metal to undergo the process of welding to be welded or joined to other surfaces. All alloy steels have good weldability. With the combination of molybdenum, chromium, and nickel, preheating and postheating must be done while welding is carried out on large sections. Uses of alloy steel. They are used in various applications such as pipelines, auto components manufacturing, electric motors, axles and shafts of power transformers, generators, aircraft engines mounts, landing gears, wear-resistant coatings, manufacturing power electronics components, hot zones of furnaces, electrodes manufacturing, solar cell coatings, magnets, radiation shields, forging dyes, oil and petrochemical industries, production of lubricants, and smoke suppressants. Gold. In World of Warcraft, gold is definitely one of the very most important commodities. Lots of people believe that gold is extremely tough to earn amongst gamers, and most of them turn to buying gold for cash. Some individuals who did this appeared getting banned by the World of Warcraft servers, while others got their account hacked with the very people they bought gold from. Even though you can find trustworthy websites that offers gold for World of Warcraft players legally and honestly, you need to bear in mind there are plenty more methods for getting gold on your character without using real money. So, listed here are the techniques to know how to earn gold to your character effortlessly without using real money for it. Most notably, you should keep in mind that you can get a variety of professions that your character might take up in the game. Many of these characters will surely earn a lot of money because the occupation is extremely popular by most players. The initial profession is blacksmithing. This is definitely one of the secrets for making big money in the game. Characters in the game need blacksmiths to renew things. As a result of the constant requirement of renewing things, this profession will always be popular. An example can be producing sharpening stones and grinding stones. Enchanting is an alternative profession in World of Warcraft, which will make your character plenty of cash. This may deliver your character with good gold in World of Warcraft. Out of all servers in World of Warcraft, you will see that there is a large market enchanting supplies, just like shards to dust. Attempt to look into disenchanting, besides enchanting, as can easily get your character the most profit. The disenchanting skills could make you stacks of components for other enchanters, which were too lazy to get them for themselves. Engineering can also be another great profession in World of Warcraft that can assist you to make big money for the character. The engineering profession could fabricate things which are highly busy by players, like bombs, explosives, and fireworks simply to name some. Small pet vendors may also be greatly very busy. Though pets aren't really important to achieve quests and level up throughout the game, you'll discover that for whatever reason, World of Warcraft players love to get their characters small pets. Once you pick this profession to your World of Warcraft character, you may notice that will give a unique possibility for the character in making some huge cash around the game. All you need to accomplish is pick up several small pets, as you can, when you find yourself traveling through Azeroth and sell them inside the auction house. You may be amazed in respect to the amount of people aimed for small pets for his or her characters. Instance runs is an alternative great option to make money for the character in World of Warcraft. You'll find that there are a great number of instances around the game that enables you to farm green items. This is usually bought from auction houses, where you can even disenchant them with the materials they are able to supply. After you reach level 70, it is possible for you to instance alone, which will generate your character much gold. Japanese swords. The forging of samurai swords. Authentic Japanese swords are made from specialized Japanese steel, which consist of combinations of hard, high carbon content steel, and tough, low carbon content steel. There are qualities in both types of steel, both good and bad. High carbon content steel is harder, and able to hold a much sharper edge than low carbon steel, but it is brittle and can break in combat. Low carbon content steel will allow the blade to be more malleable, making it possible to absorb impacts without breaking, but this lower carbon content steel will become blunt in the process. The blacksmiths who forge authentic samurai swords take advantage of the best attributes of both of these kinds of steel. The blacksmith begins by folding and welding pieces of both types of steel several times. in order to work out most of the impurities. The high carbon content steel is then formed into a U shape, and a piece of low carbon soft steel is placed in its center. The resulting block of steel is then hammered, or drawn out, to form a rough blank that will soon be a samurai sword. At this point, it may have only a slight curvature or none at all. The curvature of a samurai sword is attained by a process of heating and quenching the sword in water or oil. In this process, the swordmaker coats the blade with several layers of moist clay slurry, which is a recipe that is unique to each swordmaker. But in general, this composition can include clay, water, sometimes ash, grinding stone powder, and/or rust. The blacksmith will coat the edge of the blade with a thinner clay layer than the sides and spine. After this, the sword is heated and then quenched in water or oil. The clay functions as heat insulation so that only the edge of the blade will be hardened with quenching. This also causes the blade to form a slight curve due to the reduced strain along the spine. The quenching process also creates the distinct wavy line down the center of the blade. This is called the heimin, which can only be seen after the sword has been polished. The heimin is where most say the beauty is to be found in samurai swords. Each heimin is unique to the sword's maker and serves as the forger's signature. After the sword blade is forged, it will then be sent to be polished. The polishing of samurai swords can take anywhere between 1 and 3 weeks. The sword polisher will use finer and finer grain polishing stones until the sword blade has a mirror finish. This process is called glazing. This will make the blade razor sharp and reduce drag, making it much easier to cut with. The curvature of a samurai sword's blade also adds to its cutting force. Chapter 6. How to make a sword. The 6-step process. The process of making a sword is more than what you see in the movies. For many people, being a blacksmith is a fantasy where you pound steel against an anvil, dip it in water, and voila! You have a completed sword ready to mow down the evil hordes of creatures that lurk in the forest. But swordmaking is much more than this. Swordmaking is both an art and a craft, and it takes hard work, a lot of practice, and a significant amount of specialized tools to create a sword. It also takes many years of practice to become proficient at this skill. Before the blacksmith or swordsmith actually starts hammering or heating the metal for a sword, there's a lot of work to be done. The sword's size, shape, properties, and metal composition all have to be decided upon. These factors determine the amount of metal, the temperatures of heating, and the specific steps in the process that have to be completed. This article doesn't cover the complete art of sword making. It will only discuss and outline the process of smiting the blade of a sword. There are many different methods for making a sword, and the art has changed over the centuries as technologies, tools, and the science of metallurgy has changed. But for the past 500 years, there's been one method that still stands as the most common. This is the 6-step method. The first step is forging. A bar of the desired metal or combination of metals is heated in a forge, and then it is hammered into shape, the shape of a sword. This hammering process can take a long time, and it is called drawing out the sword. The sword is worked on in sections, usually around 6 inches in length, and repeatedly hammered and heated until it comes into the desired shape. This process is repeated many times, and the sword is often heated, then allowed to cool without hammering. This is required by the metal to keep the desired properties of strength and flexibility. Once this step is completed, the sword is in the proper shape, but the properties of the metal make it very brittle, and something has to be done to give flexibility to it. Step 2. Annealing. Annealing softens the sword and makes it easy to grind into shape. The sword is now heated and then allowed to cool very slowly. Often it is wrapped in an insulating material to slow down this cooling. It can take as long as 24 hours, and this annealing process makes the sword soft and easy to grind. Step 3. Grinding. Now the blacksmith uses a grinder to work out the edge and point of the sword. This would also be when any engraving is added. This is not a completed sword yet. It is still much too soft, so it must be hardened. Step 4. Hardening. Now the sword is heated to a very high temperature and then placed into a quenching tank. This is what we always see in the movies. This quenching allows it to cool quickly and evenly, which will harden the metal. After this hardening, the sword is brittle, and something must be done to make it strong, yet flexible. Step 5. Tempering. Again, the blade is heated and quenched, but now the heating is at a much lower temperature than was used at the hardening. This heating/quenching cycle may be repeated several times. This tempering allows the blade to be strong, but not brittle. This is one stage where the skill and experience of the swordsmith is invaluable. It takes a trained hand and eye to understand the properties of the metal. It will have a certain amount of flexibility, yet still retain its sharp edge. Now the sword is ready for completion. Step 6. Completion. The sword blade itself is now complete. Now the additional parts will be added, such as the pommel, the guard, and the hilt. For the past 500 years, the only way to learn the art of sword making was to find a skilled blacksmith or swordsmith that was willing to take you on as an apprentice. Because of the specialized skills and tools, and the skill that is required, this tradition remains the best way to do it today. Before you invest lots of time and money in equipment and materials, you should find a master that is willing to teach you the basics of the art. You won't have to devote your life to endless hours of hammering against an anvil, and with a little perseverance, a little patience, and some practice, you will be able to make some decent swords that you can be proud of. Forging a leaf hook, a step-by-step guide. It's a fun and educational way to pick up new skills and add something different to your repertoire of projects. The leaf hook is a very simple design, and doesn't require the use of any really advanced blacksmithing techniques. Therefore, I have classified this project as easy. I will lay out the process to forging this item in a series of steps to make it simple to follow along in your own forge. Step 1. Cut your length. Cut a piece of 3/8 inch round steel to length, approximately 12 inches long, using a red-orange heat and cutting off with your hot cut hardy tool. Blacksmith's tip. There are several ways you can mark your steel when you are measuring for a cut. One method is to lay your steel ruler on the face of your anvil aligned with the back edge and measure out your desired length of the steel. Then, using the sharp edge of the back of your anvil, you can lightly mark your desired measurement by striking the steel against that edge with a hammer. You'll make a visible dent that you should be able to find easily even after heating to an orange heat. Another method for marking is using something called soapstone. It is a stone that is naturally soft, leaves a clearly visible white mark, almost like chalk, against the steel surface, and is very resistant to heat. This mark will remain quite visible, even after enduring high temperatures in the forge fire. Step 2. Forge a sharp point. Take a good orange heat at one end of your steel, then forge the tip to a shallow point. Use the far edge of the face of your anvil, holding the steel at about a 45-degree angle, and use light hammer blows to bring the tip of your steel to a point. Rotate the steel back and forth with quarter turns, using even hammer blows, to bring the steel to a shallow, sharp point. This is going to end up being the leaf end of the hook. Step 3. Create a shoulder. Now we will bring that pointed end to another orange heat and create a shoulder, about 1 inch back from the tip. To do this, measure, or just eyeball it, back 1 inch from the tip that you forged, and place that spot at a 45-degree angle on the far sharp edge of your anvil face. Using medium blows, strike the steel with the hammer face half on and half off the anvil. This will forge a ledge or shoulder into the steel. Rotate the steel a quarter turn and continue forging. The idea is to create a much narrower diameter section that is going to become the stem section of the leaf, leading into the vine. Blacksmith's tip. Try to work quickly so you can avoid taking too many heats. Taking more heats increases the scale that forms, causing you to lose mass. Each heat also increases the chances that you might burn off the leaf at this delicate end as you continue to thin out that steel. If you see sparks jumping from your steel, you have begun to burn your steel. Try to avoid heating to the point of sparking. Step 4. Draw out the stem. Taking another orange-yellow heat along about a 2-inch section, just behind the leaf where you've started to form the stem, bring the piece back to the face of the anvil. Leaving the unfinished leaf section hanging off the back edge of your anvil so you don't damage it, begin drawing out the stem portion. Create an even taper about 2 to 2.5 inches long using overlapping hammer blows, starting from the back section of the heat and working towards the stem. Make quarter-turn rotations to draw out the stem evenly all along its length. Step 5. Bring the stem back to round. By now you have probably noticed that as you are forging the stem, you are turning your round stock into square. You will find that blacksmiths do a lot of making round things square and making square things round. It's just a normal part of the process of forging steel. Now that you have drawn out your stem to your desired taper and length, you want to bring that square stem back to its original round shape. Do this by knocking the corners in. After bringing the length of the stem to a red/orange heat, hold the steel so one of the square edges is pointing straight up, and using light overlapping hammer blows, knock the corners flat so that you are creating an octagon. Do that on the quarter turn edge as well. Blacksmith's tip. Remember that everything you are doing with the hammer on the top of the steel, the anvil is doing with equal force to the bottom of the steel. That is why you only use quarter turns when bringing the square steel back to round. As you flatten the corner on the top of the square, the anvil is flattening the edge on the bottom. Once you have the octagon shape, go back again and knock the corners off the octagon, and lightly tap down any edges that persist. You should be able to do all of this in one heat. As the steel cools, it doesn't move as much under your hammer blows, and this is the ideal time to refine the surface with your hammer. You should be able to take out most of the lumps without drastically moving the steel since it has cooled a bit. Step 6. Flatten the leaf. This is where the fun begins. Get ready to watch the magic happen as the leaf takes its final shape right before your eyes. Take a good yellow heat on the leaf portion of your steel. Be careful not to burn the tip. Lay the leaf section down flat on your anvil face, and using straight up and down medium strong blows, hammer it down on the leaf section and watch it begin to flare out. Make adjustments to your hammer blows, hitting one side or the other to keep the leaf edges flaring out as equally as possible. Use stronger blows at the base of the leaf near the stem, and very light blows up near the pointed tip of the leaf. You want to keep that point, and hitting too hard can match out the sharpness of it. Step 7. Add veining detail to the leaf. There are several ways that this can be done, but the way I do it is quite simple and creates an elegant look to the detail of the leaf. Using a broad-bladed chisel with a fairly dulled point, you can strike nice smooth-looking lines into the surface of the leaf. Start by making the spine of the leaf. Beginning at the very tip, place your chisel so that it will make a line down the middle of the leaf. Strike solidly, and only once. Move the chisel back a bit to continue the line down the center of the leaf. Make sure your chisel is sitting in the groove of your last mark so that you create a single smooth line. Once you've made a line down the center, start making the angular veins. I typically make 3 veins on each side of the leaf, but that decision is entirely up to you. Make the veins at about a 45-degree angle to the center line you made. This is where the art comes in, so just have fun making your own look. Blacksmith's tip. You may have realized while reading through Step 7 that this step might be very difficult to do with only 2 hands. You really need a third hand, one to hold peace, one to hold the chisel, and one to use the hammer. So a trick I've made for myself is to take a heavy weight, in my case a few lead discs, and attach it to a chain. I've attached the end of the chain to my anvil stand, and whenever I need an extra hand to hold something down while I'm chiseling or using a punch, I throw that heavy chain over the anvil and let it hold the work down, while I free up my other hands to use the tools. There are also hold-down tools that you can forge for yourself that do a great job as well. Step 8. Create the bends in the vine. Now we are getting to the part where a vise and a bending tool can come in handy. I made a bending tool by taking some angle iron and drilling a couple pairs of holes in one face of the angle iron, one pair fairly close to each other, the other pair a bit further apart for making different size bends. I fastened a couple of smooth bolts into those holes, and when clamped into the vise, this makes a good tool to bend hot steel around. So take your piece you are working on and heat a portion of the stem a few inches back from the leaf. Using your bending tool, make about a 180-degree bend. Do this again, bending the next section about 180 degrees back. Then again, heating and bending the next section back again. You should end up with a curvy shape to the vine. This part is all open to whatever artistic inspiration you might have. Try to make the vine portion of the hook aesthetically pleasing and geometrically balanced. To finish the bends, take one last heat and bend the final portion about 90 degrees from the last bend to make the vertical portion which we will turn into the hook. Step 9. Draw out the hook. Now we will work through a process very similar to Step 2 in this guide. Forge a point to the hook end and draw it out. No need to make a shoulder here, we're just drawing out a straight taper all the way to the end of the hook. Once you've drawn out a nice even taper and are satisfied with how it looks, take that square and make it round, just like you did in Step 5. Step 10. Forge the hook and curl. Now we are getting to the functional portion of this project. Take an orange heat on the very tip of the hook portion of your piece, and using the very edge of your anvil, bend the tip over the edge of the anvil, making sure you are bending toward the back face of the piece. Rotate the piece in your hand, and begin forging that bend back on itself, creating a tiny little curl. This is both decorative and functional, as it will look great on the end of the hook, but also prevents anyone from hurting themselves on the sharp point of the taper you forged. Once you've made a small little loop, take another orange heat and quench just the tiny curl you forged. This will prevent the hammer from disturbing the curl shape too much. Now, with the curl facing up, start forging a bend on the horn of your anvil, creating the throat of the hook. You can make this portion as deep or shallow as you'd like. Step 11. Set an indent for the screw. As a finishing touch, I like to set an indent somewhere in the vine for the screw to sit in. It helps give it a finished look. Take a good red/orange heat in the section where you expect to drill a mounting hold. Using a ball-peen hammer, place the ball direction on the vine where you want to create the indent, and use a soft-faced hammer to hit the face of the ball-peen hammer. Check your work after each strike, reset your ball-peen, and strike again until you have a good indentation that you are happy with. Finishing. Now that you have forged the hook, take the piece to a wire wheel and polish it up, or simply give it a coat of beeswax while the steel is hot. Finishing is up to you, and it is a part of how you will make your hook unique. Drill a small hole in the center of your indent and hang this piece of functional art in your home. I've had my keys hanging on one for many years, and I love it. Conclusion. Blacksmithing is one of the few trades, if any, where the artisan can make the basic tools he requires, using the very same blacksmithing process for which he will be using the tools. Indeed, for many years, a blacksmith had to either go to another blacksmith to get his tools made, not always a good idea, after all, he wants to provide the competition with good equipment, or make them himself. Today's blacksmith has a huge variety of tools and equipment available, but the basics are few and have remained substantively unchanged over the centuries from the time when metalworking began. At the heart of the blacksmith's shop is the forge. This is the fireplace where the metal to be worked on is heated to a temperature where it becomes malleable. The traditional forge was just a charcoal-fired hearth with bellows to provide forced air to control the heat. Today's blacksmiths still use the same system, although many of them now use modern electric or multi-fuel furnaces. Then there are the tongs, which are used to lift the metal out of the forge and hold it while it is being worked on. A blacksmith's shop will have a range of tongs in various sizes and shapes. The size of the tong will depend on the size of the metal being worked on, and the shape of the gripping end will vary depending on how the material is to be held and whether it is to be hammered, bent, or twisted. The anvil is the blacksmith's workbench. It is made out of a large block of iron or steel and is where the heated metal is placed so it can be worked on. Accessories that are used with the anvil consist of dies called swages and fullers. The swage is like a stencil made of iron or steel and is placed between the anvil and the heated metal. The metal, when hammered, will be forced into the cutouts in the swage and take their shape. The fuller is the opposite of the swage and is placed on top of the metal and hammered into it so that a concave depression in the shape of the fuller is achieved. Swages and fuller are often used together. An example of this could be to create a small shallow dish with the fuller forcing the metal into the shape of the swage. Blacksmith shops have many standard swages and fullers ready to use, but many often need to make special ones for projects that require complex shapes to be created. A blacksmith shop will have a variety of hammers of different weights and sizes. The size of the hammerhead will vary depending on the shape that is to be created, with the largest ones being used for hammering the metal into shape, and the smaller ones for doing the finishing. Besides these basic tools, a blacksmith doing artistic work will have tools for embossing or etching on the metal. There are many more tools that modern technology has provided the blacksmith, some using state-of-the-art metalworking technology, but if a blacksmith has the basic tools mentioned above, he is in business. This has been Blacksmithing, Do-It-Yourself Projects and Information for a Blacksmith or Silversmith, written by Arthur Livingston, narrated by Nicholas Santacier, copyright 2017 by Arthur Livingston, production copyright 2017 by Arthur Livingston. Blacksmithing, Hammering Your Way Through the Business of Blacksmithing, written by Arthur Livingston, narrated by Nicholas Santacier. Chapter 1. Hammering Out Forged Round Bars. Have you ever wondered about the process of hammering out something like forged round bars or other metal creations? Probably not. But these products are used every day in a myriad of essential ways and in a variety of industries. For example, chemical plants, sugar mills, offshore oil drillers, refineries, and pipelines are just a few of the innovative industries that use these metal products on a daily basis. Each company will require a variety of manufacturing methods, such as normalized annealed treatment, and tempering and hardening treatments in their usage. Nowadays, presses and hammers are all computer-controlled machines, but it hasn't always been this way. Early processes were very antiquated and rustic. As far back as 4000 BC, iron and bronze were wrought on heated anvils to form a variety of weapons and tools. Blacksmiths in the 19th century were becoming more and more adept and skillful at creating many different products from a variety of metals. Steel became popular about then, and it was a huge success in every manufacturing process. Forged round bars descend directly from this process. Today, they are fashioned from an assortment of materials and are utilized in a variety of applications in venues like agriculture, mining, aerospace, and the automobile industry. These industries would not be able to function without the necessary use of forged round bars. Speaking of the automobile industry, the invention of the automobile really changed history for the good in so many ways. Parts and components were required that had to be invented and created from metal. In the early days of the automobile, all of these parts were hammered out and created by hand. Then, in 1930, an American company invented the first metal press machine. This allowed the automobile manufacturers to turn out cars at an increased production rate. Less skill was needed to produce these parts as well. Today, forged round bars are employed for pumps, valves, casting dies, centrifuges, compressors, generators, and heat exchangers. There just seems to be no end to industries that can take advantage of these metal marvels. These metal products are exported to many foreign countries and are found in almost every industry in America. They are designed in a variety of finishes, dimensions, and sizes to meet every need of the client. Only the best quality raw materials are used in their production, and the most up-to-date technological techniques are employed. Since there is such a high demand worldwide for these items, the stainless steel products also are quite competitive in pricing. Needless to say, forged round bars and other metal products have come a long way since the early days of tool and weapon making. And it's a good thing they have, because the world has truly become dependent upon products like this to make it successfully go round every single day. Chapter 2. Turning your projects into a business. What constitutes a blacksmith project? The answer is that just about everything a blacksmith makes is a project. A hobbyist or amateur blacksmith's project can consist of anything from making simple nails to small tools for use in the house, or decorative items such as metal coasters or candle stands. The forge shop will produce commissioned forged metal objects that can range from doorknobs to hat stands to iron gates, decorative grills, and architectural fittings. A large commercial or industrial-sized forge shop will produce machine and automobile parts, oil drilling equipment, aircraft and jet engine components, and a vast range of other items. The blacksmith artist will use his blacksmithing skills to produce works of art or decorative items that can range from small decorative pieces to architectural embellishments or busts and large outdoor sculptures. All of these qualify as blacksmith projects, but what does the blacksmith have to know and do to execute them? It's not as simple as getting an idea in the head and turning it into a finished piece of metal. Here is just a partial list of what the blacksmith needs to know to be able to execute a project successfully. Of course, he must be an expert at the art for forging and shaping metal. He must be a manager who can manage and maintain his forging shop not just in terms of operational efficiency, but also in terms of safety and profitability. While the profitability aspect does not directly apply to the amateur blacksmith, understanding the economics of the trade will ensure that the hobby does not involve more expenditure than it should. He must know what equipment he should keep available and which kinds of projects he can undertake with the materials he has. If a project requires the procurement of additional equipment, he must be able to judge the cost-effectiveness of the purchase and the long-term utilization of the equipment. He must be a materials manager and ensure that all the fuel he needs for the forge and metal he has to work with are available when he needs them. He must be able to provide estimate of cost, time, and materials for any projects he undertakes, with the knowledge that his reputation depends on his being able to meet these commitments. He must be able to perform the basic maintenance of his equipment himself, and also know when to call in experts for repairs that are beyond his abilities. He needs to be able to sketch and, if necessary, prepare detailed drawings of the project he is planning to undertake to ensure that the finished work meets the required specifications. A blacksmith needs to be a good record keeper and have details of all the projects he has done, either in a digital or hard copy form. This is required not only for accounting and audit purposes, but also to provide a prospective client with an assurance that the blacksmith will be able to undertake the proposed work. These are just a few examples of the things a blacksmith needs to be aware of, and do, to enable him to execute projects successfully. The completed project is just the tail end of a long and complicated process. Chapter 3. Blacksmith Plans. To be able to produce a finished work that is either to a commission specifications or which is sellable, the blacksmith needs to be more than just an expert metalworker. Of course, his skills are important when it comes to the quality and value of the finished product, but to be able to work to his best ability and be sure that he is making a profit on the project, the blacksmith needs to be able to plan his work and expenses. If the blacksmith is producing projects for sale, he needs to know the market rates for equivalent goods, ensure that he can match these rates while making a profit for himself, plan on what will make his product unique so that it stands out and attracts customers. It is the second of these issues that is the most complex and requires a certain amount of both technical and business knowledge. What is given below in regard to blacksmith plans for commission projects will also apply in this case. Commission projects are much more complex and require careful planning before they are quoted for and executed. Before undertaking any commissioned project, the blacksmith should ensure that he has planned for taking care of the following issues. Study the project carefully. The devil is always in the details. A slight misreading of the metal specifications or the dimensions will not only cause you to offer a wrong quote, but, if the quote is accepted, cause the final product, on which you have spent so much time, effort, and money, to be rejected. Understand the material costs, and if it is a long-term project, build in a raw material price escalation clause into your quotation. Many clients may resist this, but you can tell them that you will show proof of escalation, if any, and this will not be added to your profits. Estimate the time you will require for the project. Your time is valuable, and every hour spent on the project which is not charged for is a loss. You could have done something profitable in that period. At the same time, remember that you are quoting against competition, so keep the time frames as tight as possible. Plan around your other work and projects, adjusting them if needed and if possible, to ensure that you are able to meet the deadline you have offered or the client has demanded. If the project involves any work that you cannot do yourself but have to subcontract, ensure that your planning includes both the cost and time required for the subcontracted work. Depending on the type of project, make detailed drawings or diagrams and have these approved by the client so that there is no misunderstanding of what the finished product will be or will look like. Prepare your own time chart for completing the project with stage-wise milestones so you are able to ensure that your work is progressing on schedule. Marketing your business. The survival of any small business is dependent on efficient marketing and promotional efforts. It might be important for any solution to become advertised, to make sure that it produces a brand name recall between clients. Devoid of promoting, it is challenging and difficult to create adequate revenue to maintain the company's operation. Firms advertise their solutions largely to generate income. Income covers the expenses incurred in operating a company. Without possessing profits, there can be little to no business. You will find a few modes of promoting your business and must choose the right one. POP shows or position of purchase shows are a strong, reduced expense technique of promoting. Pop shows are brightly lit display boards which are frequently set up in retail stores. They have been popular since man started out marketing items. Even blacksmiths used pop marketing to advise potential clients of their services. These days, with technological advancements, samples are often replaced with picturesque depictions of items. Pop shows play a large part in the purchasing decisions of purchasers, as they lure them into obtaining one particular item, and often many more impulsive purchases. Pop shows are appealing ads for any array of products in any retail shop. These shows are regarded as very useful resources in promoting and endorsing. They're identified to enhance a company's income. Promoting firms usually use pop for shows as just one component of the promoting and marketing mix. This produces an influence for the buyer's thoughts and typically convinces them to buy a solution. Staged shell-out for shows arrive in a range of types. They might be uncomplicated backlit signboards promoting a product or maybe a showcase, with brand name names described. Others are glossy and artistically developed, endorsing unique lifestyle products. Pop shows are a depiction of the company and the company's products. Inside any marketing event, you are attempting to enhance the earnings margin of one's organization, so you really ought to give severe consideration to this powerful device. Chapter 4: Etsy, Facebook Interaction, and Ads, YouTube Videos. You registered and open your Etsy shop online and advertise your goods, jewelries, gold, and metals, and so on. Do you sell your handmade crafts in an Etsy shop? Are you frustrated and overwhelmed trying to get more traffic? How can you get people to your little shop when there are thousands of others on Etsy vying for position? And with the recent changes at Etsy, the floodgates of sellers has opened, making it even harder to get noticed. Well, you're not alone. Here are a few marketing techniques that you use regularly to advertise your blacksmith products. 1. Social media. Duh, right? Of course, we all know about social media marketing, but are you doing it right? It's really a fine balance of providing your followers with useful information, peppered with the occasional ad from you. Keep in mind, if all you tweet or post about are your sales, you will very quickly lose your followers. Instead, try a ratio of 5-to-1. 5 great, informative, or entertaining articles to 1 of your advertisements. Which sites are best? Good question. The big 3 are Facebook, Twitter, and LinkedIn, but Pinterest is quickly coming to the forefront. Try marketing on 3 sites and see how it goes. You can always add more later. 2. Newsletter. Remember that email list of customers you've been carefully cultivating? You've been cultivating your email list, right? Well, past, happy customers are your best friend. You've already sold them, so they're more likely to come back for more of your crafty widgets. Make your Etsy customers feel special by offering them something exclusive, like free shipping or a free gift with purchase. And if you don't have an email list yet, get on it. 3. Beef up your shop. Another duh, but seriously, it's amazing how many sellers don't bother to list their items correctly. That means keywords in your headline, but make sure it doesn't sound fake. Awesome photos, it's the biggest selling tool you have. Thoughtful tags, how would you search for your items? 4. Get involved. Etsy is a very active community. Join teams, engage in discussions, ask questions. Also favorite other shops and do some treasuries. All of these things bring attention to your shop. 5. Post daily. It's better to list 1 thing every day than to list 7 things at once. Listing daily keeps your shop closer to the top in searches. 6. Market to groups. Facebook and Yahoo both have special interest groups. Find some that allow occasional marketing of your Etsy items. 7. Craftory. Have you heard of it? Craftory.com is a site where you can post your items for sale. They have free and premium listings. The bonus is that Craftory will then tweet about your item. Double bang for your buck. If you are a crafter, Etsy can really help you get your craft business off the ground. Even if you already have a successful local craft market presence in your town, adding an online element by selling on an online marketplace like Etsy can take your craft business to the next level. By selling online through Etsy, you can access a national and international customer base. You can also interact with other sellers from all over the world and learn new crafting techniques and ideas. By putting yourself on Etsy, you move into a different level of blacksmith business, one that is growth-oriented and more in tune with online shopping and social opportunities and resources. Your business can only grow through exposure to the opportunities of an online marketplace like Etsy. There are 3 main ways that Etsy can help get your craft business off the ground. The first is that it makes your work visible and available to customers from all over the country and all over the world. As an example, my last 3 Etsy sales were to Russia, Greece, and Australia. It would be impossible to reach customers in these kinds of places without an online shop. Because Etsy is the most well-known and most international of all the online shops, it can do wonders for giving you access to these customers. Second, Etsy provides a community of other crafters and artists who are constantly sharing tips and solutions through the Etsy forums and inspiring one another through treasuries, little galleries of 12 items that members select and promote. Crafting can often be a solitary activity, so having this community of fellow crafters can push an artist to a new level of skill and professionalism. Third, Etsy provides a jumping-off point for the whole world of online marketing and social media marketing. By having a shop on Etsy, you can branch out into Facebook fan pages, Twitter, Flickr, a photo-sharing site, and the entire blogosphere. As an Etsy artist and shop owner, you have instant credibility to advertise, comment, and post contributions to online resources such as blogs and Facebook fan pages. As you go deeper into these online resources, more and more opportunities for marketing and exploring new avenues for crafting and promoting present themselves. These opportunities are much harder to find when you limit yourself to a brick-and-mortar market. Building an online craft business through Etsy can be hard at first, and can seem intimidating. New skills have to be mastered, such as photography and writing ad copy. But online selling is worth the investment of time and energy. If you are just beginning, it will play a huge role in getting your craft business off the ground. If you are established, it will bring you a whole new market of potential customers and community of fellow artists. How do I sell on Etsy? Etsy is an online global craft market where individuals can list and sell products ranging from antiques to handmade goods. Sellers here can sell handmade products, vintage products that are more than 20 years old, and supplies for crafting. Limiting the type of products that can be sold on Etsy makes this website not only a great place to sell these specific types of products, but it also makes it easier on customers who want vintage or handmade goods to find what they are looking for. In order to be successful in this marketplace, you need to know how to market and sell your goods. No matter what you are selling, the first step is to set up an Etsy shop. If you have questions about what can and can't be sold, or have questions about setting up an Etsy shop, you can refer to the seller handbook on the site itself for information on making a shop, adding billing information, adjusting communication features, and more. Once you have your shop set up, you can start listing your products for sale. Make sure that you have nice, high-quality photos of your products that will make potential customers interested in your goods. Take close-ups and full shots of all products in a well-lit area so that customers can see exactly what the product is. High-quality photos will most likely result in more sales than photos that are out of focus, taken in poor light, or which don't show the complete product. You will also want to spend some time writing accurate and thoughtful descriptions of your products. Remember that customers who browse the website are looking for handmade or vintage items that have a story behind them. There are many unique products on Etsy, so to make your products stand out, you will need to use photos and descriptions to tell potential customers why they should buy your product over other similar products. A great photo and solid product description outlining specs about the product, how it was made, and how it can be used are crucial to converting potential customers into committed buyers. You can also utilize Etsy's keyword features in order to have your product show up in searches. Be sure to pick keywords that directly relate to your product and that make sense to your target audience. Include words that describe the product, the materials, and who would use the product. Words like industrial or rustic will be appealing to certain shoppers and drive them to your shop if your type of product matches their preferences. After you have set up your shop, listed your products, and added targeted keywords, you can begin marketing your products and shop on social media sites or through a blog. You can also run ads for your products on Etsy to get more traffic to your site. Be creative not only with your products, but with how you market them to your audience. This creativity will help you land more sales and create a loyal customer base on Etsy. Chapter 5. How to create and promote a shop on Etsy. Hello there. Welcome to the world of Etsy. For those unfamiliar, Etsy is an online merchant showcase where everything is either handmade, a supply for making something handmade, or vintage. It is a wonderfully eclectic group of people dedicated not only to their craft and your enjoyment of it, but to customer service. Through teaming and conversations, merchants support one another in the sale and promotion of their goods. Does this sound like you? Read on. I started beading a number of years ago, no exact number as a true lady never reveals her age, and quickly found that I could only decorate a tree with so many ornaments and myself with so much jewelry. At the encouragement of my friends and family, I went about selling at craft fairs and the major online auction site. I found that the fees greatly impacted my bottom line. I was able to sell a few items here and there, but nothing major. I kept telling myself that this effort was more about meeting people and clearing out some inventory than anything else. Then, one sleepless evening, I found Etsy. Please don't let me steer you wrong. I'm a newbie on Etsy, and have only made sales to coworkers from my Etsy site. However, I am so excited about the site that I want to share its possibilities with you. So, before you set up an Etsy account, here are a few items to consider. 1. Setting up a store is very easy. You can choose PayPal or direct payments through Etsy, or both. I highly recommend both, so set up your PayPal to accept payments. Free to set up, marginal fee for each sale you make. 2. Think of a catchy store name that hints at your offerings. 3. Set up a light box with a light background and get some great shots of your merchandise. 4. Write descriptions of yourself, your shop, and each item you are listing. Etsy recommends at least 7 items to start. 5. Look at other shops and Etsy policies to get examples of shop policies, return policies, shipping policies, coupon code policies, etc., and write your own. 6. Log on to Etsy.com and start a store with the above information. Each item costs 20 cents to list, and you will pay commission to Etsy on each sale. Please read these policies carefully. 7. Join some teams to help you through this process. Teams have great suggestions on marketing, pricing, taking great pictures, and any number of things you'll have questions about. There are local and global teams to participate in. Find some teams with interests or locations similar to yours to really harness the power of teams. 8. Look at all of Etsy's supports, blogs, and featured shop articles. Fantastic tips there. 9. Start small and grow. I started my store with 7 items, and I am up to 32. I have 3 shop sections now: beaded ornaments, quilting supplies, and custom embroidery. The sections are easy to set up, and Etsy is very user-friendly. 10. Use Facebook and Twitter to promote your site to friends and family. In all, I found Etsy to be an incredibly easy, fun experience. I can't wait to grow my little business, and I am confident that Etsy is the place to do it. How to successfully sell jewelry on Etsy. Many people jump into an Etsy shop without taking the time to learn how to be successful at it. Educate yourself on selling first. Do's and don'ts and the stork. First, take time before stocking your shop to read the do's and don'ts of Etsy, and review some of the Quit Your Day Job articles in the official Etsy blog, called The Stork. Not only will this prepare you for what to expect, but will give you advice and suggestions from peers on how to run your Etsy shop. Education of the Etsy universe is key. Once you are in, continually refer to The Stork and the forums for help. Stock your shop with good selection. Your shop should then be stocked with a good selection of items, ranging in price so that you may eventually find and target your market. Selling all higher-priced items at first may alienate your lower-priced customer base. At first, a good selection is key. Good, clear, close-up photos are key. Gorgeous photos will encourage customers to shop with you. Grainy photos, or photos that do not show detail in your work, will not sell your item. Good photographs can be had with even the oldest, cheapest cameras if you capture natural light and know how to zoom in. Practice makes perfect. Tags and keywords will make or break you. You can have the best priced, prettiest jewelry in the world, but if it's not properly tagged or categorized, no one will ever find it. Read up on how to properly tag your item and how to use all 14 tags. If you need help, search the web as many sellers discuss this. Join a team. Join a team on Etsy. Most are free and are based on either location or theme. You may wish to join a local team and or a jewelry-themed group. Teams band together to help promote each other's items, and in turn will obtain more exposure for your items. Be prepared to work to promote your Etsy shop outside of Etsy. Etsy gives you a low-cost platform to sell your wares with a free shop, charging only minimal listing and sales fees. However, the promotion and success of your shop is up to you. You must work hard outside Etsy. Other social media used for marketing your blacksmith product to friends and the world are not only Etsy, Facebook interaction and ads, YouTube videos. You can as well go up to Pinterest, eBay, and the likes. Chapter 6. Blacksmith in the World of Warcraft. Becoming a blacksmith in the World of Warcraft can be a great way to earn extra gold, provide a beneficial service to other players, as well as make your own armor. Getting a World of Warcraft blacksmith guide can be a great way to learn all the ins and outs and tricks of the trade, so to speak, of becoming a blacksmith in the World of Warcraft. This profession is one of the most rewarding, as well as hardest to level up. Below, I will go over a brief overview of the blacksmith in the World of Warcraft, as well as some tips and benefits. 1. Swords and armor. One of the biggest benefits of becoming a blacksmith is that you are able to create many high-level weapons and armor. In fantasy RPG games, and World of Warcraft in particular, having the best armor and weapons is vital. Whether you are PvPing, raiding, soloing, or grouping, you need to have high-quality gear to be able to perform at your highest potential. Blacksmiths are an incredibly useful class to be in, because they're able to supply the best weapons and armor. If you decide to become a blacksmith, you will find that you are never short of gold. 2. Rough and coarse stones. When first becoming a blacksmith in World of Warcraft, the 2 materials you will need in order to level up are rough and coarse stones. These can be easily obtained on your own by simply mining for them. You also find veins of copper and silver that can be used to level up your blacksmithing skill. An alternative would be to buy these materials on the market, but if you are just starting out and are short on gold, then mining them is a great way to get a head start. 3. Once you reach level 75, you can visit a trainer and have your apprentice blacksmithing status upgraded to that of journeyman. At this level, you'll be able to create much more advanced armor and weaponry that will be very in demand at the higher levels. This is where the money can really start to come in. After you reach level 90, you'll need to mine silver and tin to level up. 4. Once you get to level 150, you can revisit the trainer and upgrade your status from journeyman to expert blacksmith. Once you obtain this level, many special options will be open to you, and you'll be able to infuse many stats into your armor pieces, making them even more in demand. And finally, once you reach level 220, you can upgrade from expert blacksmith to artisan blacksmithing. Becoming a blacksmith is a lot of fun, and a great way to spend your time when you're not leveling up in dungeons or raiding. Creating a video course on blacksmithing. The job of a blacksmith involves heating metal with fire to forge, make repairs, and create welds. Approximately 2/3 of blacksmiths work in manufacturing, but if you are more artistically inclined, you can use your skills to create decorative railings and gates, furniture, and sculptures from metal. Becoming a blacksmith requires physical strength, but also obtaining the proper training and developing the necessary skills. Starting to become a blacksmith. Read books about the profession and art of blacksmithing. Blacksmithing is a skill that requires a good deal of knowledge to be able to perform, even to get started, and reading about it is the quickest and easiest way to start. Some books to start with include The New Edge of the Anvil by Jack Andrews and The Art of Blacksmithing by Alex Beeler. Take classes. Attend a community college or vocational school that specializes in blacksmithing to learn basic blacksmithing skills. Start by locating community colleges and vocational schools near you. Then take a look at what kind of classes they have that deal with metalworking. Begin with a class that teaches oxyacetylene, gas, welding, to learn how to light the torch, safely handle hot metal, handle the tanks, and what safety equipment to use while welding. Try to find classes that will teach you how to control heat in the forge, whether it is coal or gas-fired. Become familiar with the blacksmithing tools, such as an anvil, hammer, tongs, and punch. If you can't find any classes near you that deal with blacksmithing tools, look for online classes and purchase your own equipment. Experiment with using these tools. In these classes, you'll learn essential skills such as drawing out, brazing, cutting, riveting, and upsetting. Take more advanced metalwork classes. Learn more modern metalworking skills that are needed to become a well-rounded blacksmith. Do this by completing the beginner metalworking classes offered either at your local community college, a vocational school, or online, and then move on to whatever intermediate and advanced classes are offered. Learn about plasma cutting, such as the distance the electrode needs to be from the metal, the angle at which the electrode should be held, and what amperage should be used to cut various thicknesses of metal. Become skilled as a MIG, metal inert gas, and TIG, tungsten inert gas, welder. MIG welding requires a spool that is continuously fed and is useful for long pieces of metal. TIG welding requires a rod and is effective for welding aluminum. Arc welding might not be a part of classical blacksmithing, but being well-rounded in your metalworking skills is important if you want to make it a career. Start building your own blacksmithing setup. Whether you're looking to become a hobbyist or you want to eventually make blacksmithing a career, you're going to eventually need your own equipment. To get started practicing blacksmithing on your own, you'll need at minimum the following equipment. A forge. A forge allows you to heat your metal so that it can be manipulated. You can either make your own forge or buy one online. Tongs, clamps, and a vise. These allow you to hold your heated metal so that it can be worked with securely and safely. An anvil. This is what you'll rest your metal on when you hit it into shape. Hammers. These are what you'll hit the metal with. They come in all manners of shapes, sizes, all for different purposes. Safety equipment. Strong leather gloves, a heavy-duty apron, and a blacksmith mask will keep you safe when dealing with dangerously hot temperatures. Most of this equipment can be bought online. Just do some research first before making a purchase. Training at blacksmithing. Join ABANA, Artists Blacksmiths Association of North America. Look for an ABANA chapter near you, then look into how to join that particular chapter. Then consider attending ABANA meetings. You'll learn more about blacksmithing, meet other blacksmiths, and get a chance to become a part of the blacksmithing community. ABANA has both professional blacksmiths and hobbyists. Join an apprenticeship program where you'll be able to hone the necessary skills to become a blacksmith. Search online for blacksmithing apprenticeships and internships near you. The structure of these apprenticeships vary, but generally it involves being paired with a master blacksmith for one-on-one training and experience building. Some blacksmithing apprenticeship programs require qualification through a demonstration of basic blacksmithing skills, but many are designed for beginners with no blacksmithing experience. Further advance your skill by joining a journeyman program. By becoming a journeyman, you will work in the shop of a professional blacksmith. Here you can learn a variety of styles and possibly work with architects to design details for new and old construction. ABANA provides the means to join a journeyman program through their website. Here you can fill out their questionnaire and join their registry, where aspiring blacksmiths can match with professional blacksmiths looking for understudies. To join a journeyman program, you'll need to meet a minimum level of skill and competency with blacksmithing and metalworking in general. The skills a journeyman is expected to know are listed on ABANA's website and include things such as drawing out, heat treating, and basic metallurgy. Establish your own blacksmith shop. If you're more the self-starter type, you might want to give starting your own small blacksmithing business a shot. Once you've got the tools and the know-how, it becomes a matter of marketing and business skills. Most blacksmiths who make their own shop focus on artistic blacksmithing. Consider starting out by learning how to make custom metal art, like swords and sculptures, and start selling them through commerce websites like Etsy. The key to creating a successful self-start blacksmith shop is to slowly build a base of satisfied customers and make a name for yourself. There's a market out there for expertly handcrafted functional metal art. Finding your place in that market is your goal. Find a job as a commercial blacksmith. Manufacturers of many types of machines, transportation, and railings require the skills of blacksmiths. Like with many other niche industries, the key to getting your foot in the door is networking. Once you have the skills, the next step is meeting the right people, which goes back to joining blacksmith associations and affiliates and getting involved. One way into a commercial blacksmithing job is to start working for the professional blacksmith you learned from in a journeyman or apprenticeship program. Become a demonstrator of blacksmith techniques at living history museums or fairs. Apply for these positions directly or through blacksmithing guilds or chapters. These jobs may be hard to come by, but if you're in the right place at the right time, you can find them. These jobs involve demonstrating the art of blacksmithing to the public. Chapter 7. A Future in Blacksmithing? Setting up your own blacksmith shop isn't very difficult. Well, let's be honest, I haven't finished mine yet because I simply don't have the space. But acquiring the equipment and materials wasn't difficult. The basics of blacksmithing really haven't changed much in the last 1,000 years. The modern blacksmith has a basic setup that is fairly simple, straightforward, and not all that different from the medieval blacksmith. You need fire, air, water, anvil, hammer, and tongs. Sure, as with any other hobby or trade, there are plenty of extras like vices, power hammers, and belt sanders that make crafting easier and provide opportunity to embellish, but the basics are still very simple. Just about anything you need for blacksmithing is available new through sites like Centaur Forge, and even some of it on Amazon. But another option is buying vintage blacksmith tools. You can find these in antique shops and flea markets. Also, they are available on Craigslist and eBay. Of course, shipping an anvil through the mail is expensive. Certain things you will need will have to be bought local. Chapter 8. Ways to maximize the space in your shop. Considered as the first ever factory in the world, blacksmithing remains to be a very important industry today. Blacksmiths are responsible in producing well-crafted, functional metals. A blacksmith produces items that range from simple nails to small decorative pieces, to architectural embellishments, and even sculptures. Blacksmith shops differ in size and layout, and even complexities. Some may just have the basic furnishings, while some shops may have modern or advanced equipment. Nevertheless, whatever the design of a blacksmith zone, the very basic equipment and functions are the same. Now, you might be interested to know what's inside a blacksmith shop. A blacksmith shop typically has these basic apparatus: the forge, bellows, a tool bench, and trough. The very most important part of a blacksmith zone is the forge. The forge is used to heat metals at very high temperatures. The process of heating metals is done to soften the metals for it to be shaped into some functional and useful objects. The most common type of forge is the coal-fed forge. Next to the forge is the bellows, which are air pumps that are used to force air into the forge. The bellows are especially necessary in increasing the rate of fire to produce temperature. In most modern blacksmith shops, however, electric fans are being substituted for bellows because its speed can be controlled. The tool bench contains the tools used in manipulating metal forms. The tools typically consist of different tongs to handle metals and hammers to shape the metals. Also, the shop contains an anvil where the hot metals are pounded and hammered. Anvils usually come in different shapes, sizes, and even weights in order to produce the precise shape of the metals which the blacksmith wanted. The blacksmith shop also has the trough, which is used for quenching metals, and it contains water or oil to cool metals for easy handling. Blacksmithing is still a very important industry even in today's modern and mostly industrialized world. Almost everything now has parts made of expertly crafted metal. These objects are almost always made by blacksmiths, the people who turn raw metal into useful and functional objects. To do this, they must have a place to make and manipulate these metals. This blacksmith zone is their shop. The blacksmith shop is said to be the world's first factories, and it might have well been true, because during old times, most metal items were produced in just a handful of blacksmith shops. Today, the blacksmith trade has evolved, but still they retain their basic functions and apparatuses. The blacksmith shop usually contains the forge, the bellows, a tool bench, and a trough, among other things. The forge is probably the most important feature of the blacksmith zone. It is here that the metal is heated to very high temperatures so that it is soft enough to be shaped into useful items. In coal-fed forges, there's usually a coal hopper next to it, containing fuel. It is important to have the hopper near the forge so that it is ready if more fuel is needed to bring the heat to adequate levels. The bellows can be found near the forge. These are air pumps used to force air into the forge. With more air, it is possible to increase the rate of fire, and consequently, the temperature. In the olden days, the bellows were manually operated by the blacksmith or an assistant. Modern blacksmith shops have replaced these tiresome bellows with electric fans. These blowers give more precise control over the bellow because its speed can be controlled. It is connected to the forge by a series of pipes and ducts. Next to these is the tool bench. Here you can find the various tools that a blacksmith uses to manipulate metal. There are a variety of tongs here that the blacksmith would use to handle the metals. The hammers used to shape the metals are also found here. They may come in different sizes, and most of them have different purposes. Near the tool bench is the anvil. It is here that the hot metal is pounded and hammered into shape. A blacksmith may have many different sizes and shapes of anvils. They also come in different weights, so metals can be precisely shaped into any form that the blacksmith desires. After the metal has been shaped, it is usually too hot to be finished and detailed. That's where the quenching trough comes in. After the blacksmith is done shaping the metal, he usually immerses it into the quenching trough. The trough contains water or oil that cools the metal sufficiently to make it easier to handle. Chapter 9. Extra hard cutting tool materials. Ultra-hard materials are the result of modern research and development. The last century witnessed extraordinary growth in many fields of science and technology, including material science. The latest developments in science and technology resulted in the use of very hard materials in mechanical, automobile, and aviation fields. This in turn resulted in the development of new ultra-hard cutting materials to machine these parts. Beside carbide cutting tools, several other ultra-hard materials, like ceramic, polycrystalline diamond, PCD, monocrystalline diamond, MCD, natural diamond, diamond coatings on cutting tools, synthetic monocrystalline diamonds, as well as polycrystalline cubic boron nitride, are developed. Polycrystalline diamond, PCD. Polycrystalline diamond plates are manufactured by high temperature and high pressure process, where the diamond coating is directly combined with a carbide support. Polycrystalline diamond is made by sintering of high-quality diamond powder with metallic binder. Depending upon the application, polycrystalline diamond materials are available in various grain sizes. For example, the diamond with rough grain sizes are used for making cutting tools with excellent wear resistance due to its ability to retain cutting edge for a longer period. In case you need very high surface finish on machines parts, then ultra-micro grain sizes are highly preferred. Medium grain sizes are used for general all-purpose cutting tools, since it is a balance between high wear resistance of rough grain size and superior finish of ultra-micro grains. This makes the medium grain size polycrystalline diamond as an excellent ultra-hard material for manufacturing high-quality metal cutting tools. Natural diamonds. Monocrystalline diamond, MKD, is natural diamond out of pure carbon. These natural diamonds enable the production of geometric defined flutes with absolutely notch-free flutes. Natural diamond, MKD, is one of the ultra-hard materials which is suitable for achieving very high surface finishes for mirror-bright surfaces, machining of non-ferrous materials, micromachining, and machining of titanium without burr. Synthetic monocrystalline diamond. Further research and development resulted in synthetic monocrystalline diamonds, which are available in triangles and rectangles, with an edge length of approximately 8 mm. The natural diamonds often contain nitrogen, and it could have varying hardness and thermal conductivity, whereas the synthetic monocrystalline diamonds have uniform structure with constant thermal conductivity and less internal stress. Today, synthetic monocrystalline diamonds are being produced in various shapes and sizes, which offers great application possibilities of this ultra-hard material in future. Researchers have found considerable improvements in synthetic monocrystalline tool life, improved surface finish, and constant wear behavior compared to other ultra-hard materials like PCD and natural diamond. Diamond film coating, CVD process. Diamond film coatings are done to improve the surface hardness of cutting tools. Generally, diamond film coatings can be classified into two: the thin diamond film coating with a layer thickness of approximately 5 to 20 microns, and thick diamond film coating with a layer thickness of approximately 0.5 millimeters. Higher thermal and chemical stability and ultra-surface hardness are the advantages of diamond film coating. Low fracture toughness is the disadvantage of diamond film coatings. And compared to polycrystalline diamonds, no binder is used while producing diamond film coatings, which causes higher splintery fracture. Diamond film-coated ultra-hard materials are best suitable for machining of aluminum alloys with high silicium contents, as well as graphite and carbon. Tests show very good use of diamond-coated tools in machining plastics, gold alloys, and wood machining. Polycrystalline cubic boron nitride, CBN. Polycrystalline cubic boron nitride is the hardest cutting material after ultra-hard materials like ceramics and diamond. CNB is manufactured by a sinter process of high temperature and pressure, using selected particles of cubic boron nitride. Depending on various cutting applications, polycrystalline cubic boron nitride are available with different binder phases, as well as in fine, medium, and rough grain structure. CNB is an ultra-hard material with excellent thermal stability up to 1200 degrees. Polycrystalline cubic nitride with low CBN contents is mainly used in precision machining of hardened steel and other hard ferrous materials. Metal cutting tools. Metal cutting tools are made from tool steel, which refers to a range of alloy and carbon steels that have the right properties and are well suited to be made into metal cutting tools. The distinctive hardness of these steels, their ability to hold a cutting edge, and their resistance to deformation at high temperatures makes them ideal. Metal cutting tools are generally used in a heat-treated state. The tool steel used for metal cutting tools are made to a different number of grades, and choice of grade depends on whether a keen cutting edge is necessary. The higher grade carbon steels are typically used for applications such as stamping dies or metal cutting tools. Metal cutting tools are used widely in industry and are used for the cutting, shaping, and removal of unwanted metal. Cutting tools such as drill bits and reamers are used for cutting holes through various metals, while other metal cutting tools such as dies and taps are used to cut screw threads. There are many different types of metal cutting tools which are used for a wide variety of purposes, and some of the more common ones can include drill bits, grinding wheels, milling cutters / circular saws / slot drills, etc., laser cutting, reamers, broaches, dies and taps. Drilling is a rotary cutting operation for producing holes. The tool most widely used for this purpose is the twist drill. The twist drill has helical cutting edges, which when rotated and fed forward into the material under pressure, will cut away chips of the metal, which are removed from the hole by the helical flutes, which run along most of its length. Milling is another important process. in which the workpiece is shaped by means of a rotating cutter provided with a number of teeth or cutting edges. Usually the material is fed against the milling cutter, either longitudinal, transverse, or vertical. Milling machines are very versatile and can be used for a great variety of work, including screw thread cutting. In circular milling, the cutter and workpiece are rotated. In straight milling, the cutter rotates and the workpiece performs a straight bead motion. Grinding is the operation in which an abrasive wheel or disc is used to remove metal. It is generally employed as a finishing treatment to give already machined parts the necessary precision by the removal of excess metal. It is also used as a process in its own right, e.g., for roughly forged or cast parts, or for the shaping of hard materials. Grinding wheels are made from artificial abrasives, usually the aluminum oxide or the silicon carbide type, embedded in suitable bonding agents. Wheels are available in a vast number of different combinations of abrasive, grain size, type of bond, hardness of bond, and structure. Chisels. Chisels are useful for chipping off extra or unwanted pieces of metal. Chisels are used in the metal cutting industry for both cold or hot cutting processes. A cold chisel is used to hack off waste bits of metal. Cold chisels are used for a wide range of metal cutting tasks that include cutting rivets, thin metal sheets, square-shaped corners, and keyholes, among several others. Most models of cold chisels are burnt to a hard brown by using strong steel and flame-tempering technology to improve its cutting ability. Diamond-shaped chisels are used to cut out sharp corners and narrow grooves in metals, while hot chisels, the chisel is heated to make it softer, can be used to help it cut through the metal. Round-headed chisels are used to cut indentations in metal surfaces. Chisels are particularly suited to chipping metals that are softer than themselves. Chisels must work in tandem with the right hammer. An oversized chisel will tend to absorb the blow from a lighter hammer and will be unable to do any useful cutting. Industrial shears. These are specially made from carbonated steel and can be used to cut through metals such as steel, stainless steel, as well as aluminum. Metal cutting shears typically resemble a pair of scissors and come in varying sizes. They can range from smaller, portable, manual models to huge, floor-mounted or bench-mounted versions. Bigger models of metal shears are operated pneumatically or electrically. Despite the use of advanced and automated machinery in the metal cutting industry, manual cutting tools continue to be an integral part of the metal cutting manufacturing process. 1. Hand shears. Hand shears are powered either electrically or pneumatically. They can cut even very tough steels. Operation manual will always come with your hand shear tool, so be sure to read them thoroughly before starting your operation. Hand shears are most often used to blank out sheet metal, which is the process to cut the general shape for the piece to be formed. You should get a professional-grade heavy-duty electric hand shear for high-speed cutting and trimming of metals. Some can cut up to 150 inches per minute on a number 14-gauge steel. The cutting head can swivel 360 degrees for straight, sideways, or angled cutting position. Electric hand shears can save you many hours of time, and they make very long and precise cuts, either curved or straight. 2. Snips. Snips look like scissors. However, they are very heavy-duty and are the most common cutting tools in sheet metal fabrication work. You will need at least 3 pairs of snips: left cutting, right cutting, and straight cutting. 3. Files. Files are used to smooth out the cut edge you make on metals. They are just used as often as any other hand tools in metal shops. There are so many types of files available, usually classified by shape, length, and cut. Chapter 10. What is D2 steel? D2 is vacuum heat treated, raised to a high temperature, and cooled by a vacuum process. D2 is often referred to as tool steel for its unique properties that make it an ideal material for manufacturing tooling and industrial knives. D2 is often used for punches and dies, shear blades, press brake tooling, granulator blades, dicers and rotors, recycling blades, as well as many other applications. D2 is considered high-carbon, high-chromium tool steel that is manufactured for high abrasive wear applications. D2 can be heat-treated to RC64. There are also several options for augmenting the finished tools or industrial knives for further wear resistance. One such process is to cryogenically treat the D2. By cryogenically treating the steel, the D2 is brought to a -400 degrees Fahrenheit. This will condense the molecular structure of the steel. Because of its properties, it is a difficult material to machine and requires a special wheel for surface grinding or sharpening after heat treatment. It is also very stable during the heat treating process, so you can manufacture thin parts and leave minimal material for finished grinding. The high chromium content gives this grade some similar properties to stainless steel, although it is not classified as a stainless steel and is magnetic, which is important for the grinding process. In the world of industrial knives, D2 is the ideal material in most cases. Granulator blades, recycling machine blades, shear blades, and slitters, to mention only a few, are mostly made with D2. D2 is used in the plastics, metalworking, paper, and recycling and rubber industries, and is specified for a wide range of machinery applications. D2 is ideal for the remanufacturing of new replacement blades for granulators, rotors, shears, slitters, paper knives, ice scrapers, as well as custom applications and one-off blades. When it comes to grinding, resurfacing, or sharpening D2, special abrasive wheels are used in machines that are designed to precisely grind and/or sharpen the D2 to very tight tolerances. Because of its hardening capability, D2 is ideal for the industrial knife world, as it can maintain a very sharp edge. Its hardness characteristics make the steel ideal for applications that require impact resistance. It is important that when looking for aftermarket knives, you consider the material and hardness to achieve the maximum life from your blades. Make sure you are dealing with a company that specializes in your specific applications. For over 2 decades, AccuGrind of New England has been a leader in industrial knives. Jewelry making tools. Their proper usage. In making your own jewelry, the first things you want to prepare are your materials and tools. Many are still questioning what are those tools mostly needed in making jewelry, and how they can use it, or are they really important? Do they need all those tools in making jewelry? Well, sometimes it is very necessary to have all those tools ready. It is much better to be well equipped always. In this article, you will be taught about the tools in making jewelry and their proper usage. Starting to work with tools can be dangerous if you are not familiar with them, so finding some safety tips in jewelry making advice is important to do. Even learning a simple design like how to make a button bracelet will require some knowledge and safety guidelines to ensure you don't injure yourself. Pliers. This jewelry making tool comes with different shapes and sizes. These are the examples of pliers. Long flat nose, long round/flat nose pliers, round nose pliers, split ring pliers, round/concave pliers, nylon jaws, flat nose pliers, and bead crimping pliers. Long flat nose. This kind of pliers is used to form, shape, gold, or straighten wire without damaging the metal itself. Long round flat nose/flat nose pliers. This is used to loop, bend, or coil wire or flat stock without damaging the metal. Round nose pliers. This kind of pliers have 2 conical jaws. This is used in making loops with beading wire or other materials. The loop size is determined by how far the jaws are made. If you want to make small loops, make it near the tip of this pliers. Otherwise, large loops are made near the hinge of the pliers. Split ring pliers. This is a special kind of pliers used to hold a split ring open for connecting other components to the ring. Simply insert the curved tip of the pliers into the ring side, and by squeezing the pliers handles, it opens split rings. In adding charms or beads to the ring, the curved tip securely holds the ring. Round/concave pliers. This kind of pliers is used to reshape ring shanks, and it is also used in bending or forming wire and flat stock. Nylon jaws, flat nose pliers. This kind of pliers have jaws that are made from nylon. The nylon is softer than the jewelry wire that cannot make scratch or mark the jewelry wire. This is frequently used in straightening wire and squeezing wire components to flatten and harden them. When straightening, the wire is pulled through the jaws of nylon jaw pliers. Bead crimping pliers. This is used in squeezing tubes and beads into smoothly round-shaped crimps without making unwanted sharp edges. Cutter. Example: end cutter, side cutter, and jewelry snipper. End cutter. The end of this cutter have jaws that are blunt with blades perpendicular to the handles. This is used in making sharp and clean cuts on wire. The blades at the end provide more cutting leverage. Side cutter. This kind of cutter have jaws that are pointed and angled. The angle is designed nearly parallel to the handles, so that the cut is made at the top side of the cutter. Jewelry snipper. The jaws of this cutter are pointed. This is commonly used for sheet, wire, and beading cord or string. Tweezers. This hand tool is used in picking up small objects like beads. It is also used in grasping and holding beads and bead stringing thread. Chapter 11. Metal Railing. Almost every home has stairs of some kind. They may be stairs that lead to your front door, stairs that lead to your second story, or stairs that lead to your downstairs. The type of handrails you choose can accentuate whatever type of stairs you have in your home. Handrails. Handrails are a way to add elegance and creativity to your home if you use the right kind of handrails. Metal railings are a popular style of handrail, as well as wrought iron and wood. Although the main reason and purpose for handrails is safety, this does not mean that they can't be attractive and aesthetically appealing to you and your guests. Handrails are much more attractive and versatile than what was offered years ago. Today, we have choices of wood, iron, aluminum, and steel. You'll have so many choices that you won't know which one to get for your stairs. When handrails were first used years ago, the most common type was pieces of pipes that were mounted to the stairs, walls, or ramps. While they served their purpose for safety, they weren't very attractive. Today, we can have the combination of safety and beauty. Whether you're choosing handrails for your home or business, you have a large selection to choose from, including metal railings, exquisitely designed wooden railings, or wrought iron railings to name just a few of the most popular. Contractors and architects have knowledge, tools, and the sense of creativity to design some of the most beautiful handrails to complement their stairs and entire home. Considerations when choosing handrails. When you choose handrails for your home or business, appearance will probably be your first consideration, followed by safety, or vice versa. However, other things need to be considered, such as design, cost, maintenance, and local regulations. There are established codes that need to be considered regarding the Americans with Disabilities Act for stairs and ramps, particularly if you are in business. There are specific dimensions and heights which are recommended. Unlike days of the past when handrails were simple and plain, today you have the opportunity to choose from brass handrails, steel handrails, wood handrails, or glass handrails, and balustrades. The type of handrails you choose is a matter of personal preference, as well as your choice of balustrades, which are not available in lightweight materials as opposed to the concrete and stone ones of the past. Balcony railings are necessary, and we often do not think of them as something that could enhance the look of our house. But, just looking at the photos of old European houses, especially in London, you will see why decorative railings have kept their popularity throughout history. The most popular were wrought iron railings, and even today, they offer endless possibility for making your simple house stand out. How to choose decorative railing for your balcony. Such can be made of any material, and the choice will have to do with the architecture of your house, with your taste, and with your budget. When you think of changing the look of your house, think of such as an investment. Sometimes, very ornate railing will look great with a simple house line. Simple, modern railing, on the other hand, will not fit well with a Victorian or traditional house. The only exception is when the house has too many decorative elements already and cannot take one more. Wrought iron railings. Wrought iron railings have been the must in London houses for centuries. The design and color fashion changed through history. In the first half of the 19th century, all London railings were painted green to blend into a background of foliage. The same color was used for fences, gates, and garden furniture. In 1840, Humphrey Repton, famous English landscape designer, recommended a bronze finish, made by powdering copper dust. Following the death of Prince Albert in 1861, iron railings were painted black as a sign of mourning. The fashion, or a habit, continued to this day. The use of iron decorative railings. Iron decorative railings have a distinction that they can be made in any number of shapes and forms in order to fit a certain architecture or particular taste. Decorative railings for the outside balconies, windows, roof gardens, or stair railing can make a particularly striking addition to a house, even the simplest one, and give it the architectural distinction it completely lacked before. If your house has no balcony, add a few decorative railings below your upper story windows, and you will have immediate decorative elements. Flat roofs, even if they are not used, can benefit from a lovely decorative railing. Making a roof garden would not only provide a wonderful green space for your family, but would greatly increase the value of your house. Inside of the house can also use railings. For stairs, landings, room dividers, spiral staircases, even as a decorative wall hanging. Although the aesthetic value of decorative railing cannot be doubted, the safety is their primary role. and it is important to learn the existing codes and follow them to the letter. Safety of your family always comes first. Jackets, tailored suits, and coats are some of the most exquisite kind of clothing, which is why it is important to properly care for these garments. Choosing good coat hangers is essential to preserving the quality, form, and integrity of merchandise on display. The first step in choosing the right kind of hangers is to be familiar with different garment types. Wooden types are best for supporting the heavy weight of suits and coats. Thickly molded plastic hangers are also an alternative in providing support to heavy garments. More than the weight, the dimensions of the garment should also be taken into account. The hanger should be wide enough to support the entire length of the shoulder line. Shorter sized ones will cause garments to sag, and the sharp points caused by ones that are too long can create dimples along the shoulder length. The texture of certain garments should also be surveyed. Some textures cause clothing to slip off. Hangers covered in velvet or other padding can prove to be a stylish solution to this problem. For better presentation, coat hangers should be uniform in look. Using similar-looking varieties will be easier on the eyes and look more organized and orderly. The look of the hangers should also match the overall store decor. Upscale boutiques often use wooden varieties, while the same kind may seem unfitting at a discount store. Because coat hangers are bulkier and stockier, space and storage should also be considered before bulk purchasing. The thickness of the hangers should not only be able to support garments, but should also fit well into the allotted area for display. It would prove advantageous to stick to one trusted hanger supplier for stock. Sourcing regularly from one store makes purchasing simpler, may allow for discounts, and provides more uniformity in hangers. How to make coat hangers. One of the most fascinating crafts can often be technically best out of waste, and a coat hanger Christmas tree is just one of them. This small tree can be your ideal Christmas decoration without giving a hint of what it is made of. It is a rather simple design, where only the construction of the frame requires some tricks, and the rest follows. Therefore, once the frame is done, small kids under adult supervision, or grown-up kids, can complete the remaining portion. This style of tree also allows a lot of room for experimentation in terms of colors and decoration. Go through the following instructions to erect your Christmas tree. Material requirements. Coat hangers, preferably with rotational hooks. 3 in number if made of metal. 6 in number if made of plastic. Twist ties, craft wire, electrical tape, or strings. Glue. A pair of scissors. Garlands in sparkling green color or as per choice. Electrical lights. Ornaments, stars, cones, ribbons, etc. Toys or other decorations. Construction. The frame intended here will look like a tripod stand. Remember, a hanger resembles a triangle with 2 equal sides, and the hook is located at the angle formed by these sides. Step 1. If you have taken plastic hangers, make 3 pairs. Superimpose 2 hangers and tie or tape them to add strength. If you have metal hangers, skip this step. Step 2. Position a hanger or pair in such a way that one of the equal sides is towards the floor and the other one vertical. Step 3. Hold 2 of them similarly, joining firmly their vertical sides together at a small angle. Recall what any 2 sides of a tripod appear like. The alignment of the hooks will take care of itself. Rotational hooks are helpful in case any adjustment is needed here. Step 4. Join the 3rd hanger towards the larger angle formed by the 2 hangers in Step 3. For better balancing, all the 3 legs should have equal angles between them. Step 5. Place the structure upright. Step 6. Stick one end of the garland of your choice to the top of the frame. Step 7. Wrap it around and continue until the lowest point. Decoration. Step 1. Use standalone or string of Christmas lights around the tree in linear or hanging fashion. Step 2. Adorn your tree with twisted ribbon, ornaments, cones, candies, and other decorative items. This has been Blacksmithing, Hammering Your Way Through the Business of Blacksmithing, written by Arthur Livingston, narrated by Nicholas Santacier. Copyright 2017 by Arthur Livingston. Production copyright 2017 by Arthur Livingston. Blacksmithing. The Sophisticated Art of Blacksmithing. A Beginner's Guide. Written by Arthur Livingston. Narrated by Nicholas Santacier. Introduction. Most people often misunderstand the art of blacksmithing. Some believe that blacksmithing is the trade of angry people, that beating and pounding metal is a great way to exercise out your anger and frustration. This, however, is far from true. Blacksmithing is a trade that requires a calm, patient, and controlled mind. The essence of the trade is not necessarily strength, but patience and perseverance. Anything done in anger will never yield anything beautiful. Anything done in haste is often half regrettable. The secret is to hit the metal with the right amount of force. The art of blacksmithing possesses an almost Zen-like quality, with its discipline of the mind. Beautiful ironworks is the product of a calculated and clear mind, of patiently waiting as your metals take shape. This book is written for anyone who has an interest in learning the trade of blacksmithing. In it, you'll find an outlined history of the trade to help you understand its roots and why only a few people know about it now. You will also learn more about the different tools used in this trade and be educated about the metals used and the primary techniques employed by blacksmiths. There are also practical applications and small projects if ever you wish to fully experience and learn the trade. Lastly, you'll find plenty of beginner's tips and vocabulary lists to help you better understand how things work. I hope that this book will help you a lot in your quest for knowledge about the art of blacksmithing. Fast facts. The Iron Bridge in Shropshire, England. Built in 1779, this bridge spans the Severn River and is the world's first iron bridge. This bridge is made from cast iron segments. It is about 100 feet and 6 inches long and took 20 months to build. It has 1,700 individual pieces, with the largest weighing over 5 tons. Each piece is forged individually to fit with each other. Chapter 1. History. What is a blacksmith? The term blacksmith is a combination of two words, black and smith. Generally, a smith is someone who works with metal. The Iron Age and blacksmithing came hand in hand. The Iron Age started when a primitive man discovered a faster way to melt iron ore to produce iron. Although lead is naturally common, it was never found in great quantities. Iron, on the other hand, is well distributed around the world. The first sources of iron came from meteorites and iron nodules from bogs and clay banks. Iron, as a blacksmithing material, became widely popular due to the construction of smelters or bloomeries. Bloomeries were strategically built in areas with an abundant supply of charcoal, iron ores, and flux. These bloomeries are beehive-like furnaces built into rocks that can withstand repeated heating. They have a vent on top and another opening on the side. Here, iron deposits were melted or smelted to separate the metal from the rocks. However, smelting iron requires hard work. Not only did they need a large supply of charcoal to fuel the furnaces, they also needed to find an ore that can produce the most amount of iron with the least amount of work. The iron ore was placed inside the furnace, and the charcoal contained within was set alight. As the charcoal burned hotter, the iron flowed and formed blooms. These blooms are then taken, hammered, and shaped to ingots. For decades, blacksmithing remained a crude art. It took years for people to get a grasp of metallurgy. Blacksmiths experimented on iron to create a more durable metal. They also developed processes to temper and harden the metal. They played with the carbon content of iron to make it more usable. They developed the alloys and the different tools, steels that we use today. As the iron industry prospered, so did blacksmithing. Blacksmithing eventually branched out to different specialties. By 1793, Eli Whitney, who was a genius in mass-producing metal parts, heralded the Industrial Revolution. He created and patented the cotton gin machine. This machine not only simplified cotton production, it also greatly reduced the cost of cotton. In turn, as the cotton industry prospered, the blacksmiths were called upon to provide the plows to plant cotton, the wheels, and horses shod, and build better roads to transport products. By 1838, John Deere was able to manufacture a superior plow that is made from steel. This single event sparked a significant milestone: iron versus steel. This also introduced the era of steam power. Inside the blacksmith's forges, things changed as well. bellows were replaced by rotary fan blowers, and in larger shops, a steam-powered trip hammer was also used. During 1860, lumber was starting to cost less, and this made most people want to live in houses instead of log cabins. But as lumber grew cheaper, nails became more expensive. At the time, a single nail was made a piece at a time by a blacksmith, and as the demand grew bigger, people began to find ways to mass-produce nails and make it more affordable. Wheeling's LaBelle Nail Company answered the people's demands and started producing nails in massive amounts. They manufactured nails and sold it at an affordable price. This robbed the blacksmiths of their foremost product. By the late 1800s, railroads connected the country, and hardware is now mass-produced in factories and sold in shops. Automobiles came into the picture, and as World War I ended, so did wagon making. This further pushed blacksmithing trade close to non-existence. Some blacksmiths were able to transit from working on wagons to automobiles. The Studebaker family, well known for their Conestoga wagons, is an example of the ones who made the successful transition. Although the blacksmithing trade did not disappear overnight, it was nearly non-existent by the 1950s. The trade survived just barely, and only as a specialty. This era, however, was considered the golden age for architectural ironwork. A lot of America's most precious ironwork was made during this era. The Samuel Yellin Ironworks in Philadelphia was commissioned to create the iron grills for the windows of the Federal Reserve Bank. Some blacksmiths managed by commissioning intricate ironworks for mansions. These commissioned ironwork pieces involved stairs, window grills, gates, door knockers, and chandeliers. Decorative ironworks, however, came to an end as the Great Depression and the Second World War loomed. Fast facts: blacksmiths and dentistry. Dentistry was established around 19th century, but before that, people who cured dental problems were called tooth drawers or tooth pullers. The term was coined due to the small pliers tooth drawers used to extract a tooth. Blacksmith was more associated with this discipline mainly because they are responsible for creating and supplying the pliers that the tooth drawers used. Chapter 2. Basic Tools. In this chapter, you'll be introduced to the blacksmith's workplace and to the different tools that they use. First up is the forge. At the heart of every blacksmith's workplace is a hearth. This hearth is the forge or the smithy. Some people refer to the workplace as a forge, but in reality, the forge is actually the hearth of fire used to heat the metals. Back in the medieval times, charcoal and charcoal residues called coke are primarily used to fuel the Back in the medieval times, charcoal and charcoal residues called coke are primarily used to fuel the forges. Wood is heated hot enough but is deprived of oxygen to leave carbon behind, which then produces charcoal. Coke is a byproduct of charcoal that can also be utilized as a forge fuel. Nowadays, gas forges are available, and it offers a more convenient substitute to coal forges. Gas forges can heat more small ingots at the same time. It thus, however, produces lower heat value compared to charcoal forges. The lower heat requires the ingots to be in the forge longer to melt. The longer heating time risks highly oxidizing the ingot. To avoid unnecessary oxidization, a special kind of flux is added. Charcoal forges are prized for their higher heat value and less oxidation risks. Next is the anvil. An anvil is a heavy block of metal upon which hot metals are shaped, cut, and hammered. The earliest anvil was just a slab of rock. In time, other materials were used such as bronze, wrought iron, and steel. Most anvils nowadays are made from steel, although cheap ones are constructed from cast irons. Be creative enough, and you could also hand forge one from a piece of railroad track or from an old machine. Through the years, the shape of the anvil also evolved, from just a flat surface to the shape we all recognize now. The anvil design we know today is called the London pattern, which became commonplace during the 1800s. The length and size of an anvil can vary, but the key features are all the same. A standard design features a horn, a pritchel hole, a hardy hole, a face, and a step. The horn is the curved front end of the anvil. This part is used to curve and to draw out the metal. Some anvils have multiple horns to provide a variety of curves. The face is the hard and flat surface of the anvil. This is where most of the hammering happens. This area often sports two holes, the Pritchell hole and the Hardy hole. Although both holes can be utilized to bore a hole through metal, it can also be used to secure a variety of tools like chisels. The only difference is the shape of holes. A Pritchell hole is round-shaped, while a Hardy hole is square-shaped. The step is the area below the face and next to the horn. This part is mainly used for cutting metal. Tip: for practical purposes, you have to attach your anvil to a pedestal. Most blacksmiths use a tree stump because the wood absorbs the blows and reduces the rebound created by hammering. Make sure that your anvil is positioned right for your height, meaning not too high that you'll have difficulty reaching, and not too low that you'll have to stoop to work. There are 3 types of the hammers used for blacksmithing. These are the cross-peen, the ball-peen, and the engineer's hammer. The most widely used hammer for blacksmithing is the cross-peen hammer. It possesses a large diameter face on one side and a narrower peen on the other side. On the other hand, the ball-peen hammer's face has a smaller diameter, and the peen is roundish or ball-shaped. Lastly, we have the engineer's hammer, or the hand sledges. These have softer faces made for cold metal pounding, and are heavier compared to the other hammers. For beginners, it is advisable to choose either a cross-peen or a ball-peen hammer. However, it is best to pick one that feels most comfortable to work with. Consider the weight of the hammer and the type of work to be done when looking for a hammer. Once you start heating ingots, chances are you'll need a good tong. Vices or tongs are fireproofed hand extensions that you could use to safely hold hot metal. There are a variety of tongs that you can use depending on your requirements, but there are only 3 types of vices. The first is the leg vise. The leg vise is named for its long legs and comes with a built-in stand. The machinist vise is usually built from steel or cast iron. It is usually bolted to a bench and possesses removable jaws. The last type is the foot vise. This type of vise is not suitable to be the main vise. It is operated by applying pressure to the pedal for the jaws to grip. Tip: when looking for a tong or a vise, always check the jaws if they are easily operable and in good working condition. The water trough is also an essential part of the forge. Any old drum or bucket could be used for this purpose. The water trough is used for jousting water into the forge and for cooling the metal. When setting things up inside your workplace, it is advisable to keep the anvil and the water trough near the forge. This setup is more efficient as it lessens the amount of time needed to walk from the forge to the anvil or from the forge to the water trough. Since you'll be working with hot and cold metal, you'll need to have separate sets of tools for working with each. For hot metal work, the main consideration is the length. Tools should be long enough to keep the hot metal a safe distance away from the body. Remember, tools for hot metal work should be dipped in water regularly to avoid deforming the tools. Chisels are used for cutting metal. Hot chisels are more slender than cold chisels. A suitable hot chisel for blacksmithing would be made from steel alloys with much less carbon content. Cold chisels, on the other hand, are usually made from steel alloy containing at least 0.875 carbons. Another tool used for cutting is the set. Again, there are separate sets for working with hot and cold metals. Make sure you get both and use them appropriately. Sets are made and designed for use under a sledgehammer. Cold sets are stouter than cold chisels and are fitted with a handle on one side. A twisted hazel or iron rod is usually looped around the end part of the set to make the handle. Hot sets are commonly hafted like a hammer. Hardies are chisels that fit the Hardy hole of the anvil. It is best to have a variety of sets, chisels, and Hardies to meet the requirement of any job. Punches and drifts are used to bore holes into the metal. Punches used for hard work normally have a longer handle and are rotted. A drift has 2 tapered ends, with one end tapered longer than the other. These are inserted into the hole made by a slot punch to round or enlarge the hole. Fullers are chisel-like tools used to form shoulders, to create special shapes in metal, and to draw down in a particular direction. Swages are used to shape metals. The bottom swage is fitted into the hole of the anvil to secure it in place, and the upper swage functions as the shaping tool. It is best to have a variety of swages come in different shapes and sizes. Other necessary tools you'll be needing would include flatters, hand mandrels, bolsters, axes, and hacksaws. It is also advisable to keep empty cans nearby, which you can use for a variety of purposes, like storing smaller tools. Clean sand is also a must in your arsenal, because you can use this as a flux for welding. Fast facts. Anvil firing. Anvil firing is the practice of launching an anvil into the air with the aid of gunpowder. One anvil is placed face down and is filled with gunpowder. A second anvil is placed right face up on top of the first anvil. The gunpowder is ignited to shoot the anvil up. The height of the anvil's trajectory depends on the weight of the anvil and the amount and quality of the gunpowder used. This practice is used to substitute for fireworks and is a traditional practice to commemorate St. Clement's Day. St. Clement is the patron pope of blacksmiths. Chapter 3. Know Your Metals. Now that we have a better understanding of the workplace and the tools employed in blacksmithing, let us focus on the materials typically used by blacksmiths. Iron is the second most widely distributed metal next to aluminum, and the fourth most abundant element. People have, in fact, been using it for centuries, before the rise in its popularity during the 14th century, after the invention of smelting furnaces. Iron has a melting point of 1,538 degrees Celsius, a boiling point of 2,862 degrees Celsius, and an atomic number of 26. Iron ores are rock formations from which metallic iron can be extracted. It makes up about 5% of the Earth's crust and is among the most abundant rock elements in the world. Sedimentary rocks rich in iron, or banded iron formations, BIFs, are the most important iron ore resources. BIFs are usually of Precambrian age, or over 541 million years old. Almost 98% of the world's iron ore is processed to create steel. Steel comprises up to 90% of the world's metal. A lot of iron ore mines employ beneficiation to improve and upgrade the physical properties of harvested iron. Ore processing facilities are constructed on mines to allow beneficiation of contaminated and low-grade iron ores. There are different kinds of beneficiation processes. One beneficiation process is called pelletizing. This process is ideal for powdery or very fine ores. Powdery iron ores are shaped and formed into pellets. Another beneficiation treatment is sintering. The sintering treatment involves heating and incorporating coke, crushed limestone, and/or other additives into the iron ores. Additives used include coke fines, waste from furnace exhaust gas, and scale, which is a byproduct of rolling mill operations. Carburization is a beneficiation treatment that involves adding a very minimal amount of carbon into iron. The addition of carbon, or other additives, makes iron significantly harder and stronger. Steel is iron with a very small amount of carbon, usually about 0.2 to 2.1% out of the whole. Steel making has been employed by mankind for nearly 4,000 years. Pig iron refers to smelting iron ores, either in sinter, lump, or pellet form, and adding carbon fuel. The remaining impurities of pig iron are removed through oxidation. These impurities include phosphorus, sulfur, and silicon. The great thing about steel is that it is very recyclable, and the recycling process is actually very economic. Recycling steel requires less energy than producing new steel. Recycled steel even has the same strength as new ones. There are 5 types of steel. Stainless steel is rust-resistant and is one of the cheapest metals to produce and reproduce. Cobalt steel is distinctive for its bluish color. It is also rust-resistant and temperature-stable. This means that it can withstand extreme heat and friction. However, cobalt steel has a tendency of cracking and breaking when subjected to heavy weight or pressure. Carbon steel contains a lot more carbon and comes in 2 forms: high alloy steel and high carbon steel. Both forms are soft, malleable, cost-efficient, and cheap. However, if not protected properly from oxidation, this type of steel will succumb to corrosion and rusting. Carbide steel, as the name suggests, contains carbide as an alloying additive. Carbide makes the steel stronger and extremely dense or heavy. However, carbide produces a fume that can cause fibrosis when inhaled. This type of steel is hazardous and requires professional handling. high-speed steel, or HSS. This type of steel is very resistant to abrasion, making it the most used steel in toolmaking. HSS is also very affordable and is often mass-produced. Wrought iron has a lower carbon content compared to steel and cast iron. This type of iron is often considered as the traditional for blacksmithing. Before modern purification standards, wrought iron was considered as pure iron. However, this is certainly not the case. Wrought iron is, in fact, the end product of puddling a pig iron. That said, it is more expensive than steel. Wrought iron is very ductile and malleable. It is also favored by blacksmiths as material for decorative ironwork. The further addition of carbon, about 2.2% to 4%, into wrought iron results in cast iron. Cast iron is harder than steel, but is more prone to breaking and is less workable. However, it is comparatively easier to cast and has a relatively lower melting point. The most suitable steel alloys for smithing are those that have lower grades and only have carbon as an alloying element. A steel alloy with about 0.5% of carbon is recommended for most basic projects. A sharp-edged tool requires steel is best used on alloys with up to 1.5% carbon content. You can find these alloys at steel yards and buy them by the bulk. Alloys can also be bought at your local hardware store, although they are pricier and there tends to be a limited selection. Otherwise, you could also use scrap metals, old bed frames, springs, and rebar. If you are using these kinds of odds and bits, however, it is best to avoid plated, painted, or galvanized bits, as they give off toxic fumes upon heating. Rust in scraps is not a problem, because rust will usually flake off when heated. Fast facts. Ancient steel. People have been making steel for centuries. The earliest evidence of steelmaking was a piece of ironware. This ironware was about 4,000 years old and was unearthed at an archaeological site in Anatolia. Chapter 4. Blacksmithing 101. Now that we know the tools and metals that are often used, it is time to heat up the forge and take the hammer. Keeping it hot. The fire in the forge should be maintained at all times. When lighting the forge, you have to make sure to remove any clinkers first. These clinkers would stick and obstruct the air hole and can deform the metal. Keep the fire as small as possible. You should also make sure that the fire is directly below the metal that you are heating. Anywhere else, and the fire becomes useless. Know that varying types of metals require different temperatures in order for it to work. A dull red fire is suitable for annealing and hardening high carbon steels. Medium red fires are for medium carbon steels. A bright red fire is perfect for annealing mild steels. High carbon steels are best forged at either orange or yellow fires. Medium carbon steel should be forged at yellow fires, while mild steel is forged at bright yellow fires. Tip. Monitor the color changes of the metal in the forge. Thinner and smaller pieces tend to heat faster and ensure the metal heats evenly. Metal shaping is a lot like shaping clay. The only difference is that metal shaping is much more strenuous work and requires a lot more prep. First of all, you need to heat the metal in order to shape it. It takes about 1,400 degrees Celsius to heat metal enough to make it workable. The safest way to know when your metal is ready to work with would be when it has turned into an orange or yellow color. If you reach temps higher than 1,600 degrees Celsius, your metal will turn white and melt. Reheat metal when it turns a light red shade. Chances are you will have to reheat your metal repeatedly until your work is done. But the good news is, mistakes are often forgivable in blacksmithing. You just have to reheat the metal and try again. Hammer it right. Hammering requires control, accuracy, and precision. You need to calculate the amount of strength you have to apply in order for the metal to take shape the way you want it to. Hasty and uncontrolled pounding will get you nowhere, so practice is important if you're still a beginner. First, make sure that the hammer is well balanced and just the right size for you. Hold the hammer lightly, but firmly, and maintain at least an inch distance between your pinky finger and the edge of the hammer. Use your whole arm when swinging, and try to keep your elbow as close to your body as possible. Control is more important than strength in your hammer stroke. Assess the metal as you pound it. Adjust your position, angle, and hammer grip, and stroke as you work. Forging techniques. There are different ways to apply force and shape metals. The first is called drawing out. This process lengthens the metal by reducing its width and depth. In this process, the piece of metal grows thinner and thinner as it lengthens. This technique is also done to create sharp edges. To do this, you have to strike the metal flat with the peen side of the hammer. Be sure to rotate the metal every few strikes. Review your metal and see if it is thinning out or growing longer in the way you want it to. Next is upsetting. In this technique, the main idea is to add volume to a metal piece. To upset your piece, you need your metal to be near welding heat, or yellow-white. The higher temperature needed in this technique may cause the metal to bend in the wrong place if you're not careful. To avoid this, you have to wet the space right beneath the part you are working on. To upset a metal properly, you have to hold it tight and hit it squarely with the hammer. Rotate the piece after each individual blow and continue hammering until it reaches the desired shape. Alternately, you could also place the heated part of the metal face down on the anvil and hammer the part you need to. The tapering technique is identical in procedure with drawing out. However, in this technique, the main objective is not just to lengthen the metal, but to add a pointed or tapered end as well. To do this, you need to place the heated part of the metal at a 45-degree angle on the anvil. Strike it squarely with the flat face of the hammer. At every few strikes, you have to rotate the metal. Reheat the metal if needed. There are different ways to twist or bend metals. You could use a bending tool, or you could use a vise. You could also lay the heated metal part over a form, like the anvil's horn, and hammer it down to bend it. But if you want to scroll your metal, it is advisable to taper the ends first. Place the metal over the horn and hammer until it starts to curve. Repeat and reheat as needed. To punch a hole into a metal, you need to heat the metal up to forging heat. Place it on the face of the anvil and secure the piece with a vise. Position the punch where you want the hole to be in, and then strike down with your hammer. After a few hits, cool down the punch to avoid deformation. When the punch is nearly through, move the metal piece over to the hole of the anvil, and turn the metal to the other side. Drive the punch through to the other side. Connecting metals. Here I will discuss how you connect metals. The first way is through the use of rivets. Rivets are like metal pins, or a thick nail, except for its lack of a pointed end. First, take the two pieces of metal that you want to hold together and bore similar-sized holes in each piece. Find a rivet that fits perfectly on both holes, and then heat it. When it is hot enough, take it out with a tong and slide it inside both holes. Upset the flat end of the rivet to create a head, and you're done. The other way is through forge welding the pieces together. This technique is used to join metals permanently and seamlessly. For this, you have to heat the metal pieces until it turns white. Place the pieces on your anvil and sprinkle borax on it. Next, you need to stick the pieces together and hammer it down until both pieces are joined properly. Finishing. So, what happens after you've finished forming your metal in the way you wanted to? You can't just set it aside. You need to properly finish the job. For this, you can use heat treatment. This involves heating metal pieces up to a certain temperature and then cooling it in a controlled way. There are different ways to do this depending on what you want from your metal. These are: annealing is usually done as a preparation before hardening. A metal piece is annealed by slowly heating it up to cherry red and then burying it in ashes to cool it down. This process can remove stresses from within the metal. Normalizing is done to remove stress caused by forging. Like annealing, the metal piece is heated to a cherry red, but is left out to cool naturally. Hardening, on the other hand, is done to make the metal stronger and more wear-resistant. This treatment involves cooling the heated metal by submerging it completely in room temperature water or oil. To do this, heat your finished piece in the forge slowly and evenly until it turns a cherry red color. Watch it carefully and make sure not to overheat it. Once it reaches the desired temperature, quench it or submerge it in water. Softening or tempering treatment reduces hardness and strength, but restores ductility and increases toughness. This is necessary to make your metal piece more ductile and malleable. After quenching your metal piece, return it to the forge and heat it slowly until it turns cherry red. When it turns cherry red, remove it from the heat and place it on top of your anvil until it cools and turns to black. After this, leave your metal piece to sit out at room temperature and continue to cool. Or you can also place it in a container with perlite and leave it overnight. There are also additional steps that you need to know to further protect your piece from rust and corrosion. You can apply beeswax, linseed oil, paint, or varnish. Beeswax and linseed oil can protect your piece from rust, and it leaves off a black matte finish. Heat the metal piece to black heat, and then apply beeswax or linseed oil to the metal piece with a rug or a brush. Buff the piece with cotton cloth for added shine. Fast facts: Damascus steel. Damascus steel is a type of steel that is mainly used in sword making. It was said that swords made from Damascus steel were sharp enough to split a feather even in midair. These swords are distinguishable by a watery or damask pattern imprinted on their blades. Bladesmiths who made these kinds of swords are very secretive about their methods, and thus the technique on making these kind of steel was lost to modern day. Chapter 5. Practical Applications. In this chapter, you'll find simplified step-by-step instructions about simple ironwork projects for you to try to practice. It consists of detailed instruction on how to make your own blacksmithing tools from scratch and scrap. The best way to put your knowledge to the test is to create tools. Also, it is important for blacksmiths to learn and experience how to hand forge their own tool. Not only will doing so save you money on having to buy a set, it also makes the tools a bit more special, as it was created by your own hands. Toolmaking project number 1. Nails. What you'll need: nail header and a piece of 1/4 inch round or square steel stock. Equipment needed: anvil, hot chisels or hot sets, hand torch, hammer, nail heading tool. Instructions. 1. Draw out and taper the end of your steel stock. 2. Make a shoulder while drawing out the stock. Use the roundish side of the anvil to create the shoulder. 3. Reduce the stock to a square cross-section and make sure that the diameter is about half of the original stock. 4. Taper slightly towards the end to create a pointed tip. 5. Cut the stock about 3/8 inches above the shoulder. This extra stock will be the head of the nail. 6. Heat only the head of the nail by using a torch. 7. When it is hot enough, insert the nail into the heading tool. 8. Position the heading tool on the anvil face with the nail protruding into the pritchel hole. 9. The first hammer blow should knock the head over and center it on the nail shaft. 10. Hammer straight down once, then once on each side, and finished off with a hammer blow in the middle. 11. Remove the finished nail from the anvil and allow normalizing. Toolmaking project number 2. Round punch. What you'll need: used vehicle coil spring. Equipment: hammer, anvil, hot sets or hot chisel. Instructions. 1. Measure out and cut at least a 200mm long piece from the coil spring. 2. Heat and hammer this piece along the curves to straighten it. 3. Once you have a straight piece of metal, it is time to taper out one end. 4. Form the striking end by drawing out and then flattening one side. 5. Draw down the other end of the punch. 6. Leave the finished product to normalize. Toolmaking project number 3. Hot chisel. What you'll need: old car haft shaft. Equipment: hot sets, hammer, anvil, torch, bucket full of water for quenching, files or grinders. Instructions. With a hot set, remove the grilled part of the car shaft. Heat the area under the grilled part of the half shaft. 2. Position the hot set on the area that you wish to cut and hammer down. 3. Rotate the half shaft with every few blows to ensure even cutting, and remember to quench the hot set as well. 4. Finish cutting the grilled part against the horn of the anvil. 5. Cut the shaft to the appropriate length, usually about 400mm, with the hot set. 6. Taper by drawing down and flattening one end of the haft shaft. 7. Draw down the blade section to spread it out. This should result in a curved and long cutting edge. 8. File or ground the cutting edge. Toolmaking project number 4. Cold chisel. What you'll need: one 150mm long coil spring. Equipment: hammer, anvil, hot file or grinders, grinding steel, bucket full of water for quenching. Instructions: 1. Straighten the coil spring as you did with the punch. 2. Taper one end by drawing down. Flatten the top end by striking it straight down. This is striking end of the cold chisel. 3. Draw down the other end to form the cutting side of the chisel. Continue to taper until you have a sharp edge. 4. Strike the sides of the cutting edge to prevent it from spreading out. 5. Hot file or grind the cutting edge. 6. To harden the chisel, heat blade up until it turns into a cherry red color. However, only do this up to a quarter of the shaft. 7. When it reaches the cherry red color, quench the chisel in a bucket full of water. 8. Slowly move the chisel up and down the water bucket, but keep the blade properly submerged. 9. As the tip gets cool enough, remove the chisel from the water. 10. Clean the chisel along and near the blade with the use of a grinding steel. Do not place your chisel on the anvil, as this will cool your chisel too quickly. 11. Monitor for temperature colors. When the chisel starts turning purple, quench it in a bucket of water. 12. For the second quenching, the water in the bucket should only cover the blade part of the chisel. Leave the chisel in the bucket until it has completely cooled off. Toolmaking project number 5. Hot set. What you'll need: a piece of strong and thick leaf spring and one 10mm long round section mild steel rod. Equipment: hot sets or hot chisels, bucket full of water for quenching, hammer, anvil, tongs, hot punch, hot drift, rulers, clamps and vices, grinding steel or steel file. Instructions: 1. Measure out approximately 40mm from the leaf spring to the mark. 2. Cut the marked part with a hot chisel or a hot set. Quench the cutting tool every few blows. 3. Stop cutting when you have reached halfway through and break it against the edge of the anvil. 4. With the help of a tong, forge the rough edge of the metal piece into a wedge. 5. Flatten the top of the thicker end and forge in the corners around the face. This will be the striking end of the hot set. 6. Take the punch and position it on one side, approximately nearer to the striking end. Hammer straight down until you are about 3/4 through. Reposition the metal on the pritchel hole and finish up on the other side. 7. Enlarge the hole with the drift until it reaches the suitable width to fit the steel rod. 8. Do the same on the end of the wedge. The holes should be perfectly aligned with each other. Measure out the distance between these holes. 9. Work on the blade end by forging it down. Hammer down the sides if the blade starts to spread out. 10. Forge down to a slightly tapered point on end of the steel rod. 11. Measure out about 150mm from the tapered end and bend the metal into a U shape. 12. The width of the U should be identical to the measured distance between the holes. 13. Slip the steel rod into the tool head and flatten down the bend. 14. Fold the longer end of the steel under the tool head. The tapered end should stick out to one side. 15. Hold the tapered end with a tong and then wrap it around the base of the tool head. 16. Form the handle by bending about 15mm from the end and angling at about 90 degrees. 17. File or ground the blade using grinding steel or a steel file. Toolmaking project number 6. Do-it-yourself blacksmithing anvil. What you'll need: a section of railroad track, about 18 inches, and an 18-inch truck leaf spring. Equipment: torch, hammer, clamp, drill, drum full of water. Instructions: 1. Search for a good piece of scrap railroad track. 2. Shape the railroad track to look like an anvil. With the help of a torch, soften and cut the railroad track and form a horn on one side. 3. To make the face of the anvil, anneal the truck leaf spring. When it cools, weld it on top of the railroad track up to the base of the horn. 4. Use clamps to flatten the section of spring into the top of the railroad track. Spot weld in some places before completely welding the pieces together. 5. Create a pritchel hole by boring a hole about 5/16 inch in size. 6. Create a hardy hole by drilling a hole about 5/8 inches wide. 7. Heat the finished anvil for 30 minutes and then quench it in a drum full of water. Continue adding water to the drum to completely cool the anvil. Toolmaking project number 7. Tongs. What you'll need: 1/4 inch by 3/4 inch by 8 inch mild steel and soapstone. Equipment: ruler, center punch, hammer, clamp, slitter, drift, anvil, bucket full of water for quenching. Instructions: 1. Measure out 1 1/4 inch from the end of the steel and mark. This will become the jaws of the tong. 2. Measure out 1 inch from the jawline and mark. This will serve as the boss of the tong. 3. With a center punch, define the mark you made for the jaw. 4. Define the boss mark that you lined on the underside of the steel with a center punch. 5. Indent both sides of the boss by a half-face hammer blow. 6. Draw out the reins by alternately hammering both edges. Do this until you reach the desired length for the tong. 7. When you reach the desired length, break the corners to give the piece a more rounded edge and plenish. 8. Compare the steel pieces and even out their length. The steel pieces should be identical in length. 9. Attach the piece to a clamp. Make a 90-degree twist in the middle of the jaw and the boss. Remember to twist both pieces in the same direction. 10. Round the corners of the twist to make the jaw and the boss smooth. 11. With the use of a center punch, mark the hole for the rivet. 12. Use a slitter to start boring the hole. The slitter should be slightly bigger than the rivet that you will use. Position the slitter vertically into the boss. 13. When you are almost through cutting the hole, flip your steel and mark the point where the slitter would come through. 14. Reheat the metal and continue boring the hole on the other side of the metal. Widen the hole by driving the slitter all the way through. 15. Round the hole using a slightly larger drift. Drive the drift through each side alternately. 16. Find a rivet that will fit perfectly on the tong's rivet hole. 17. Heat the rivet up. Keep a keen eye on the rivet as you heat it to avoid burning. 18. Insert the rivet into the rivet hole and hammer it into place. 19. Heat the finished tong and work on it while it's still hot. 20. Adjust the tongs and align the reins. 21. Quench the tongs, but be sure to work them so they will not get locked in place. Toolmaking project number 8. Eye chisel. What you'll need: a straightened out piece of heavy coil spring, or an old anti-roll bar, or a thin half shaft. Just make sure that diameter of the steel is about 20 to 30 millimeters. Equipment: hammer, anvil, ruler, hot set or hot chisel, hot file or grinders. Instructions: 1. Draw down and flatten one end of the bar. This will serve as the striking area for the eye chisel. 2. measure at about 400 millimeters and cut it using a hot chisel or a hot set. 3. Drown down the blade end of the chisel and carefully taper it. 4. Forge the tapered area into a diamond shape. Work on it one side at a time to ensure that the blade end is shaping perfectly. You might need to reshape certain parts as you go, so if you want something that's really even, keep a close eye on how things are shaping out. 5. Hot file or grind the blade end. Toolmaking project number 9. Eye drift. What you'll need: a piece of a vehicle's half shaft. Equipment: ruler, anvil, hammer, hot set or hot chisel. Instructions: 1. Form the striking area of the eye drift by drawing down and tapering. 2. Cut the shaft to an appropriate length with a hot set or a hot chisel. The eye drift should be longer than the eye chisel. 3. Draw down flat about a third of the length of the shaft. 4. Forge down the corner of the tapered end. Toolmaking project number 10. Cross-peen hammer. What you'll need: old vehicle half shaft. Equipment: hot set or hot chisel. Hammer. Anvil. Hot punch. Cold chisel. Hot drift. Block of wood. Adze. Saw. Bucketful of water for quenching. Ash for annealing. Instructions: 1. Cut off the splined end of the vehicle half shaft. 2. Cut both sides to remove the creased end. Taper down this side. 3. Finish the peen by hammering 2 long ridges. 4. Position the shaft across the anvil with the peen laying crosswise. 5. Flatten a small area where you will punch in the eye. 6. Use a cold chisel to mark where you'll be punching in the eye. 7. Reheat the metal. 8. Drive the chisel about halfway into the shaft. Quench the chisel every few blows. 9. Once you're about halfway through, flip the shaft and continue punching from above facing side. 10. Drive the chisel all the way through to allow the drift to pass through. 11. Shift over on the hardy hole and drive the drift through the hole. Alternate both sides as you drive the drift through. 12. Form the cheeks of the hammer by forging the metal pushed out by the drift. 13. Insert the drift through the hole and forge down the cheeks to flatten it. 14. With a hot chisel, mark out the spot where you'll be shaping and cutting the hammerhead from. The eye should be right in the middle of the face and the peen. 15. Cut the hammerhead from the shaft. Rotate the shaft after every blow to ensure accurate cutting. 16. Remove the bulges on the face of the hammer with a hot set. 17. Support the peen on a block of wood and forge the hammer face. 18. Harden and temper the hammerhead. 19. Pick out a piece of timber with its grain running as straight as possible along its length. 20. Cut it to size. Use an adze to shape it into a rectangle. 21. Still using an adze, trim down one end of the timber to fit the eye of the hammerhead. 22. Thin down a short portion of the shaft right below the area where you'll be attaching the hammerhead. This thinner part will help absorb the shock from every use. It will make using the hammer less tiring. 23. Continue shaping the hammer shaft to the desired shape. 24. Cut a shaft on top of the shaft at about 3/4 long of the eye. 25. Make a wedge from the same wood that you used in the hammer shaft. It should be as wide as the slot that you made. 26. Fit the hammer shaft into the eye of the hammerhead. 27. Insert the wedge into the slot. Reduce the length of the wedge and then push it down firmly until it is at the same level as the shaft. 28. Make a metal wedge to secure the hammerhead in place. Cut serrations into the metal wedge with a hot chisel. 29. Drive the metal wedge vertically along the wooden wedge. Fuel-making project. Charcoal. Charcoal is commercially available and is quite abundant in most places. That said, if you're planning on blacksmithing as a profession, or even as a hobby, it would be very handy if you knew how to create charcoal from scratch. Charcoal is literally just charred coal. You can make charcoal from almost anything organic, from corn cobs to coconut husks, sugarcane and bamboo, and from fallen logs and driftwoods. Here's how to make some. You will need a large drum, something fireproof. Next, you need to drill 5 2-inch holes on one end. Then, completely remove the other end of the drum. Form a ledge on the opened end of the drum. Arrange bricks to serve as the base of the drum. Position the drum, opened end up, on top of the pre-arranged brick base. Do not obstruct the air holes on the bottom of the drum. Put paper pieces, rags, and other kindling on the very base of the drum and set it on fire. Once it is burning up, put some dry wood inside the drum until it is nearly full. Remember to put longer pieces first so they burn out longer. Restrict the air passage into the drum by applying earth. Place the lid on top and secure it, but leave at least about an inch gap for smoke to pass through. White smoke will be produced during the charring process. Once the smoke starts to turn blue, close off all air access by putting more earth at the base of the drum and by closing the lid securely. Let this burn for another 3 to 4 hours. Avoid the urge to peek at its progress during this time, as it might cause a flash fire by accident. After 4 hours, you would have to let your coal cool down completely. This should take about a day. After that, open the drum and tip it slowly to reveal the charcoal you have produced. Do-it-yourself forge. In this section, you'll learn about one of the simplest ways when it comes to building your own forge. You could set up your forge anywhere you want, but keep in mind that open flames produces more smoke and fumes that are dangerous when in an enclosed area. A chimney can help with this, but if it's not available, a completely open forge is your best option. So let's start with the materials. Some people have forges built from old bathtubs, new sink tubs, or unused grills. But for this project, we will be using some plywood, cement, and pipes. The ideal forge size is about 3 feet high by 5 feet wide. This dimension is large enough to give you enough space for a healthy fire. Build the framework by using the sturdiest wood you can find. Next, cover the framework with plywood. Make sure that the covering is strong enough to support a large amount of cement and dirt. You should now have a rectangular wooden box. Next, you have to build a stand for your forge. The forge should reach up to your waist to make it more ergonomic. For more maneuverability, you could attach wheels on the foot of your forge so you can move it around easily. Just be sure to put a stopper on the wheels to keep it steady when you're working. After attaching a stand to your forge, the next step is to make a hole on both ends of the forge. The hole should be large enough to admit a pipe. This pipe will become the air source of our forge. Insert the pipe into the hole and allow it to extend up to 8 inches high. Fill the forge with mud, bricks, or soil up to the pipe level. Drill about 20 to 25 holes on the pipe in a circular pattern. These holes will serve as the tweer or tuyere. After this, you need to mix cement for the forge. But before you pour in the cement, you need to make sure that the tweer will not be blocked by it. Make an open top and bottom square box large enough to fit the pipe. Secure these boxes on the pipes and pour in the cement. Fill the frame with cement, and when it is nearly dry, remove the wood guards. Mix a thicker concrete and use it to create a slope around the pipe. This sloped area will ensure that air reaches the fuel. The do-it-yourself forge is almost finished. It only needs an air source. There are a variety of devices that could be used as an air source for the forge. Electric blowers from vacuum cleaners or car heaters can be used as an air source. These should be connected to a rheostat to give you control over how powerful the air blast is. You could also purchase a hand-crank blower to serve as an air source. Or you could scrounge for a bellow in a junkyard or antique shops. Whichever you opt for as an air source, keep in mind that you would have to be able to control the amount of air that goes into the forge. So pick something that you're comfortable with using. Once you've figured out which contraption to use for your air source, you need to attach it to the forge. If you are right-handed, you need to connect the air source on the hole that's located on the left side when you face your forge. If you are left-handed, connect it to the right side hole when you face your forge. This will allow your more efficient hand to tend the metals when you're working. After attaching the air source to the pipe, you would still have another pipe left open. This pipe will serve as drainage for when you're cleaning the forge. You can make a lid for this pipe, or you could use a cork stopper to close it off. Chapter 7. Things to Remember. In this chapter, we'll go through the main points we've established throughout the book. The forge, the anvil, and the water trough should be placed as close to each other as much as possible. Charcoal, coke, and gas can fuel a forge. A good anvil is fundamental to successful work. There are a variety of hammers available, but the cross-peen or ball-peen hammer is most suitable to blacksmithing. The three types of vise are leg vise, foot vise, and the machinist's vise. Other tools necessary in blacksmithing includes but is not limited to the following. 1. Chisels and sets. 2. Axes. 3. Swages. 4. Punchers and drifts. 5. Augers. 6. Flatters and files. 7. Hacksaws and auger bit. 8. Specialty hammers. Iron is widely distributed and abundant throughout the world. Most iron ores are found as banded iron formations, BIFs. BIFs, or sedimentary rock formations, are over 541 million years old. Beneficiation upgrades the quality of ores. Pelletizing, sintering, and carburization are all beneficiation processes. The addition of carbon and other additives like limestone and coke improves the quality of iron. Steel only has 0.2 to 2.1% of carbon, making it harder. Stainless steel is rust-resistant, recyclable, and very affordable. Cobalt steel can withstand extreme heat and friction and is bluish in color. Carbon steel is malleable, cost-efficient, and soft, but is at risk of rusting and corrosion. Carbide steel is extremely heavy and is mainly used as support. It is also very hazardous on one's health. High-speed steel, or HSS, can withstand constant friction and is mostly used in tool making. Steel is very recyclable, and the recycling process is very economic. Steel is very cost-efficient. Steel alloy with about 0.5% of carbon is suitable for blacksmithing. Wrought iron was once considered as pure iron. Wrought iron is suitable to use for decorative ironworks. Pig iron impurities are removed through oxidation. Cast iron has more carbon content than steel and wrought iron. Cast iron is harder, but is less ductile and more brittle. The forge should reach at least 1,600 degrees Celsius. The fire should be maintained, and clinker should be removed at all cost. Understanding the color of the fire is tantamount to blacksmithing. Controlled swings are more important than strength in hammering. Drawing out is used to lengthen metal by decreasing the diameter and the depth of metal pieces. Tapering is done to create sharp ends. The process is the same with drawing out. Upsetting is employed to thicken or widen metal piece. There are a lot of ways to bend and twist a piece of metal. To bore a hole in a piece of metal, a punch is used. Rivets are used to hold pieces of metal together. Forge welding pieces allows you to join pieces together permanently and seamlessly. To forge weld, you need to heat pieces of metal to welding heat or until they turn white. Heat treatment is done as a finishing process. It involves heating the metal pieces up to a certain temperature and then cooling it. Annealing involves heating the ironwork and then burying it in ashes to cool. Hardening is done by heating the metal and then quenching it in water. To temper a piece of metal, it is reheated in the forge, quenched in water, and is placed on top of the anvil to cool. It is then transferred to an insulated container of perlite overnight. Finished ironworks need to be protected from rust by applying finishes like beeswax, linseed oil, paint, or varnish. Glossary. Alloy. A metal made from melting and mixing two or more metals. Anvil. A heavy slab of iron on which heated metal is shaped by hammering. Armorer. A blacksmith specializing in armors. Ball-peen hammer. A hammer with a ball-shaped peen and smaller diameter face. Bellows. A device that creates strong air current when pressure is applied to its side. Beneficiation. Process that improves and upgrades the quality of low-grade and contaminated iron ores. Blacksmith. Is a craftsman who deals with metal, especially iron and steel. Bladesmith. Is a blacksmith who specializes in swords and knives. Bloomeries. A beehive furnace built into a rock that is used for melting ores to get iron. Blooms. A mass of iron from the forge. Carburization. The process of combining metal with carbon. Clinkers, or leftovers from anything that is burned for too long. Coke. A residue of coal or other material which is also used as a fuel. Crosspeen hammer. A hammer with a larger diameter face and a narrow face like peen. Flux. A substance that is used to help melt or join metals. Forge. A place where metals are heated and shaped, also called a smithy. Gunsmith. A blacksmith specializing in gun parts like barrel and trigger. Locksmith. A blacksmith that specializes in locks. Ingots. A solid piece of metal that has been formed and shaped for easy storage and handling. Metallurgy. The science that deals with nature and uses of metals. Pelletizing. Process of beneficiation that shapes powdery iron ores into pellets. Rivets. A special kind of metal pin used to hold metal pieces together. Quenching. Submerging metal pieces in water. Sintering. Process of beneficiation that incorporates and agglomerates additives to iron ores. Smelters. Furnaces used to melt iron. Tongs. An object usually made from two long pieces connected either at the end or in the middle, used for holding or lifting objects. Conclusion. It has been a great pleasure to accompany you on your quest for knowledge. We hope that the information provided to you through this book would not only satisfy your curiosity, but also motivate you to try the art of blacksmithing for yourself. There is more to this ancient art form than merely pounding and shaping metal. Consider its history, and, of course, its many practical uses in our daily lives. Thanks again for buying my book. If you have a minute, please leave a positive review. You can leave your review by clicking on this link. Leave your review here. Thank you. I take reviews seriously and always look at them. This way, you are helping me provide you better content that you will love in the future. A review doesn't have to be long, just 1 or 2 sentences, and a number of stars you find appropriate. Hopefully 5, of course. Also, if I think your review is useful, I will mark it as helpful. This will help you become more known on Amazon as a decent reviewer, and will ensure that more authors will contact you with free ebooks in the future. This is how we can help each other. You can download any of my other books too. Just click on the links. This has been Blacksmithing, The Sophisticated Art of Blacksmithing, A Beginner's Guide. Written by Arthur Livingston. Narrated by Nicholas Santaseer. Copyright 2017 by Arthur Livingston. Production copyright 2017 by Arthur Livingston.